let's see here. We gotta go to YouTube. I'm gonna hit refresh on that. Hopefully that pops up. There it is. Bring that up. Make sure it's muted. Pop out the chat. Of course, the thumbnail is gonna be me looking like way over to the side because that's how the setup works. There we go. All right, how are we doing? We're not gonna have a very long intro today because I have a lot of work to do. We got a lot of soldering to do. I gotta solder my way out of a wet paper bag. This calculator, there's this. This is chat right here. That should be all active. I need to make sure to check in on the popped out Twitch. There we go. That'll be represented in social stream. Those two I don't need anymore. These are my moderating windows. Got it. All right. Whew. I slept like a lead brick last night. I don't know what the deal was, but I must have been tired. I just passed completely out, and when I woke up, I was like completely sore, just like hurting. I'm good now, though. I feel good. I feel a little tired as usual. What do we got going on? Not much. Not much really happened in one day. Not much. Not a whole lot. Bing, 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 bing. This song's so weird. Love it though. Yeah, we're all ready to go. Oh, so yeah, my parts came in the mail. Ha ha. Ha 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 ha. Ha, yes. Have you ever seen a group of dual op amps that look so wrong? These are at least useful switching transistors. These are TIP 122s, but this is not the 10 MCP 6004s that I ordered by a long shot. These are good switching transistors though, so it's not like they won't go to use, but TIP 122s, like, what do you do with TIP 122s? It's like motor control with those. They're powerful MOSFETs. It's one of those jelly bean components, at least. 100 volt, 5 amp TO220. And a Darlington transistor is when you take a small sensitive transistor and you hook it up with a big burly transistor, and those two make a really good pair because then you can, with like a small signal, you can trigger a big voltage. It helps you kind of ramp up. It's the low explosive setting off the high explosive. And so this one has a built-in flyback diode because you're supposed to be switching big stuff that's gonna like fly back. It'll have coils and things that'll react. TIP 122 project. Let's just see what we get here. Adjustable voltage power supply. Introduction to the TIP 122. Here we go. In today, David Watson clearly sounds like, he's in London, so in today's tutorial, we're gonna have a look at a detailed introduction to TIP 122. It's a Darlington braces NPN transistor. All right, works like an ordinary NPN. Hello, friends. I am not AI. Works like an ordinary NPN, but it consists of a Darlington pair. It has a decent collector current assembly of nearly 5 amps, and its gain is around 1,000. This transistor can bear 100 volts around collector and emitter terminals. It's not that you're not going to switch AC with this thing, right? You would be, I don't know where you would find 100 volts DC, but what you would want slightly different. You need different types of silicon switching to do AC switching. But 100 volts can also be unintentionally induced by like a coil or something like that. What's up, Smith Clay? Hey, you just subscribed. For how long? 31 months. That is significant, man. Thank you very much, Smith Clay. This album has some amazing guitar. This is Spangle that I'm playing in the background here for the intro. Of course, nobody's gonna hear it because I have 6 people listening to this music. Nobody else will ever hear it. Here's some links, blah, blah, blah. Darlington NPN transistor, ordinary NPN, but it consists of a Darlington pair, so 5 amps, gains around 1,000. Famous at its higher gain of current, which is, this is just what was written in the paragraph before. Using such loads, use higher current and used for such submissions which require higher amplification. Did you write this? Did you really write this? Transistor consumes less voltage, only 5 volts across the base of the emitter. Therefore, it can be effortlessly organized, triggered by a logical expedient, such as a microcontroller. What? It's not well written. The precaution has to check, though precaution has to do to check if the logic expedient. This is AI. This is an AI article. 31 months of Bezos's money. You are correct, sir. That's great. Thank you very much. Yeah, those primes don't remind you or anything, so. This is a bullet point. So if you're eyeing a transistor which can be effortlessly organized, find and replace has something to do with this. Modification of high power consuming loads or to intensify higher current. That doesn't make any sense. This is AI. I mean, like, it's good to have an article that like just talks about parts and like why they're useful. But I don't know. Maybe write the article. Anyway, so that's what I got in the mail instead of my MCP 6004s, which, you know, high current switching DC, not something I'm exactly doing right now. I needed my low current op amp, so we're gonna have to strategize around that because I didn't get my part. So we'll do surface mount to through hole. In the meantime, though, I am building a second one of these boards because both of these guys back here are the same thing. So I'm actually just gonna get to work. I want to get up to the point where we were on the other circuit with this circuit. So while we muse around and get distracted, I'm going to actually build this guy up without telling you guys what I'm doing, because I already did. We did it yesterday. Is this over by 1 pin? No, there's only 1 row of holes. How did I? Okay, yeah, so it is in contact with the outside there. Oops. Bezos bucks are as worthless as Cybertrucks. Bro, that's $2.50 in my pocket. Those Bezo bucks. They're potent little MFs. And if you already have Prime, you get them for free. You don't have to worry about anything. Why does this seem to me like it's over? Oh, maybe because I put it all the way out here on this one? Yeah, and I think that's part of what I actually need to do. It's in, out, ground. In a bizarrely weird way. Yeah, I take those Bezos bucks seriously. They may be nothing to you, but they're a whole subscription to me. Oop, turn on the iron. I had to use hot air on this earlier. I put the plug in the wrong spot. I mirror imaged it, which is not useful to me because the -12 is on the other end, and the -12 is only being used to power the op amps so that I can create all the ups and downs on the outputs. Man, I used to blast this album into my earbuds to the detriment of my tinnitus while in electronics lab at Drexel. It was good to tune out all the hustle and bustle to get a circuit done. I am a shaman of the sun is purple. It's a song about DMT. I used to use my brother's Prime. He always had no problem. He didn't even watch Twitch. Then suddenly it was a problem and he removed me from the family share. What the heck? What's that all about? Maybe he started watching Twitch? People can get real possessive about stuff. Come on. Oh, nope, not the right place. Maybe I can solder it from the other side. Yoink. Which row is it on? It's right there. Okay. Ah, yeah, that old hustle. I don't interact with my brother all that much. I don't know what it is. I think we just have separate lives. He has a family and everything, so, you know, that's who I interact with. Why is this not dribbling down? This should dribble down. Live with one, cut off the other. Yeah. There it goes. Now it's soldered from below. All right, let's see here. So the capacitors are going to provide me with just about everything else that I need. Just redoing the same exact circuit that we built yesterday. Okay, so negative 12 first. These are slightly different value capacitors too. Ah, jeez. Carbon copy people, huh? The sun is purple. Dimensions. I am for mental extensions. Song about DMT. What do you expect? Purple. I have a friend who's done a bunch of DMT. I don't know if his brain works so good no more. Although he's kind of always like that, so I think regardless of the DMT, I think that goes down there like that. We solder this thing in. I know this looks like I'm streaming, but I'm not explaining everything that I do. There's a difference between the two. It's not a big difference, but it's a big difference to me because when I work like this, I go much faster. Things just kind of go together much faster when I'm not explaining everything. That's why we're doing this during the intro. I'm trying to redo what we've already created so that I can build two of these circuits rather painlessly. And the two circuits are slightly different, so the areas they differ will be what comes out in this stream. Too much trust involved? Yeah, I don't know. I don't do well with altered states. It's not my thing. I've got 30 years of diabetes in which every time I was out of control, I end up in a hospital, and so that doesn't really fly when it comes to psychedelics. You need to really be in good headspace. And I don't have good headspace when I'm not in control. Actually, yeah, even when I drink too much, it becomes a big problem. So, that ain't me. All right, a little bit of this, a little bit of that, a little razzle dazzle. Mentions. I am for mental extensions. All right, next. This guy. So that would be between positive over here, right? No, this is the output. So the next one's the 3-volt regulator. What's going on here? Hold on. Let's try to get our ish together. Okay, so that one goes between there and there. So that's between ground and 3-volt output. And so we'll bend that one crossways, unlike we did with this one. We kind of messed that one up, but it's fine. Okay, that's the whole reason that one has to skip. Probably could have done something else there. Okay, let's see. So this one goes the same direction. It's going from ground to source. Oops, wrong one. This. And we can just cross that all the way over there. The constant glucose monitor actually really helped with that kind of stuff, keeping me out of my bad headspace, because I knew exactly what my glucose level was doing, and it was control. I mean, even better yet is Android APS, because now I don't have to do anything. Like, even if I eat a meal and I forget to bolus, it'll handle it. So if I were to go down that path again and try psychedelics, I could set everything up to be completely automatic diabetes-wise, and there would be just no issues at all. I could just be me. Finally, actually, you know, like oh God. I won't tell that story. I think I've told the story before, but it was a time a whole camp got mad at me for being too wild. Everybody was mad at Bother. It was weird. Nobody gets mad at me. I'm like the nicest guy in the world. They were done with my bullshit. My particular brand. A little shorter. That's probably too short. It looks too short. Oh no. What have I done? We can make that work. Ah, get out of here, bug. Long and slow. You vaporize. This one's a weird one. The gnomes have learned a new way to say hooray. It's weird, it's creepy. All right, man. Thanks for sharing that with me, I guess. Now I know what the gnomes are up to. Information I don't think I needed before today, but here it is. Okay, let's do the last capacitor, and then I can just tie that up handily in a little bow. Huh, that one even skips a hole. What would happen if I didn't skip a hole? Oh, did I not finish? Or is that goes up top? That's right, okay. Oh, I could totally put it right next to it. I don't have to skip a hole. Wait, yeah. I'll skip a hole, whatever. Let's be consistent. And then this one faces the same direction. Okay, nice and easy. Yeah, I don't do well with not knowing what the hell's going on, because my feelings of how I perceive what my body is doing have been entwined with my status for 30 years. I've had to be acutely aware of exactly how I'm feeling at a particular given point in time. And oftentimes, the correlation isn't as strong as you would think it was. So, oh, I'm feeling blank does not necessarily correspond to how I'm feeling, which is what my glucose level is, which is a kind of an odd thing. Okay, so I'm going over, and I'm going over top of this to this pin over here, right? How do we do that? Whatever emote that was, I don't have. Whatever emote that is, I do not have. And then where does this other one goes to ground? So that one goes down along and skips up, and then ground is also right here. So if I go down here, and then I need a pair of pliers. This wire for the capacitor is a lot thicker than what I'm typically dealing with. Ah, bugs! I don't know, why did Simon Posford decide that a bug, my dog freaks out when I say bug. She like will run up and jump up and look me directly in the face when I say that. She's like, what did you just say? What did you just say about a bug? But like, my dog aside, why would Spangle decide to use a bug in his song when it's like that noise? When you hear that noise, you're like, ah, get it away! Ah! Strange. Very strange. He's not a normal man. He's not a normal man. He grew up around psytrance, if I recall correctly. Very good musician, though. He does a lot of really cool songs in the psytrance space. We have met him before, Julian and I, on a New York party boat where he was performing. And the DJ booth was just like a table. It was pretty cool. It's the Gonad one? Oh. How's it going? 4069. That's gonna be too tall like that. That's way too tall. One finger in the air. Oh, that's not even down there. Oh, weird. That's weird. It's very strange. It's very strange. You should feel weird. Let's see. Can't touch it with my hand. Yeah, he loves his baritone flute, and I do too. And actually, Milton bought one of those baritone flutes, and he was playing tunes on it. I don't think you can really go wrong on the baritone flute. What are we talking about? Wait, what are we touching? Touching cloth? How do I bend this down? I need to bend it down. Oh, you can touch the wire, right? Sorry. It's that whole disconnect that I have where I don't know. If somebody makes a comment on something I said, it rolls in so late that it's tough to, I gotta re-parse the conversation in my head. Geometric shapes. I love this album. I can call this old now because it's like, it's like 20 years old, but 20-year-old psytrance. Who would have thought? Who would have thought? Bunch of old fucks listening to crazy psychedelic music. That's not from the 70s. It's weird. Yeah, I'm just because both of these are fundamentally the same module. I am just, during the intro, I'm getting shit done because I'm starting to get a lot of anxiety in my life for some reason. And I think it's mostly the added workload of uploading VODs has just got me kind of buzzing. And so I decided to do this on the side to get ahead of things. Also, the dog is taking up a lot of my time. A lot of walks, a lot of kisses. It's an unfortunate job that I have decided to take on myself, but I will persevere in getting all of the kissies. But anyway, it's I don't know, I'm just doing this to take a little bit of control back in my life. And so that the workload is a little bit lesser. So basically I'm jumping under this thing. Sleeping to Aphex Twin? I mean, I guess I kind of understand that. I of all people, I do understand that. That's like, but it's like falling asleep to the music of a junkyard metal. What are those things? Why a thresher or something like that? Death Clock. Well, Death Clock's actually pretty good. That's actually pretty good metal, to be fair. How do we do it on the other circuit? What did I do here? Look, I popped down, and I just went doot doot. I just did a little newt newt. Okay, well, we can do a little newt newt here. I guess what I need to do is bend. Oh, is this one taller than the other one? Wait a minute. No, I'm going to pop out right here, and then I just go doot newt. And I'll connect those two. Ah. That's true. If you train yourself to sleep to it, you'll be immune to waking up from random noises. That's a good point. Something about morning people. They're the least considerate people I've ever seen in my entire life. Is that right? Did I get that distance right? Yeah, I think that'll work out. Oh, these aren't gripping properly. Little world music vibe here. Oops, too far, too far. Give this back. There we go. Damn it! Hey, Mr. Yan, how's it going? How you do? How you do? Okay, the turn in the wire, there we go. It like fell in. Is it, where am I going to? I'm going to T. Done with meetings for the day. I was thinking about that. I haven't been to a meeting in a long time, and I've seen streamers who complain about office-related stuff, and they've never had an office job. What would it be like if I had to do a meeting these days? What would get me to go to a meeting? Did the whole wire that I just tried to do fall out? The answer may surprise you. God damn it! A streamer meeting would be the most inane thing ever, but I guess some communities of streamers kind of coordinate themselves. The electronics people that I know are hilariously bad at doing that. We always have the intentions of doing stuff together, but never the overlap in schedule or the final sort of push to do anything. And I would love to collaborate with some of these crazy eggheads that Twitch has. I am sort of a part of the Knowledge Fellowship, the TKF, on Twitch. It's where a lot of the professorial types come from around here, like Cosmo Quest, who's a hell of a lot smarter than I could ever give myself credit for being, and folks like them, the horologist and the paleontologizing. Those are all TKF people. Of which they have included me for some reason. I guess I sort of am educational. It's where I get the delusion that I'm actually educational content as I sit here and curse. I'm a lucky man for not having meetings. Yeah, it's like, what do I do? What do I do? Nothing is hitting this pin here. Why is nothing hitting this pin here? That is ground. This is also ground. Oh yeah, so we could just, yeah, that just goes straight out. Okay, good. You're a smart guy, you just get sidetracked by the memes. I mean, that's what we're here for. Why else would we be on Twitch? I could have some integrity and go to YouTube, but... Oh wait, I am. Speaking of which... Oh no, I popped out YouTube chat. YouTube chat's up here. Ooh, my glucose level is going up and up and up. My mouth is getting dry. I'm thirsty. Thirsty for diabetes, I guess. Stunkenfluppt. None of these tools are correct. Feels like a football. This wire is a little bit too thick for me to manipulate with my normal tools. Like these tweezers would have been what I would use to make this bend here, and I seem to not be able to. I could go up and just push it downwards and get my nail under it. Here I go. See, I'm explaining stuff again, and I'm not in the business. I'm not in the business of explaining right now. I'm trying to get this done. You get so used to it, though, explaining every single movement, every nuanced twitch. Get a little accordion work going on. It's pretty nice. Pretty nice. Pretty nice. Hey, nicey nice. That's another little personal meme that comes from a Spangle song. It might be on this album, I'm not sure. The song is called Roll Us a Giant, I think, is what the title is, but the Fingernail did not enjoy that. Oh, we've got this stuff that'll make you see fairies for 3 days. Nicey nice. Roll us a giant. That's the whole like exchange in the song. And it's a 20-freaking-year-old Psytrance song, and I'm still saying it like people would know what the hell I'm talking about. What's wrong with me? What is my problem? You're dumb. That's what your problem is. Boom, boom, boom. All right, let's see. Yeah, the time that I totally blasted myself on this album was when I was recreating a wire wrap circuit for a senior design teammates electronics class, and they just blatantly took credit for it. And I sat there, recreated the entire circuit for them because I needed them to do other work for our design team. There we go. Yeah, that'll do. Okay, that only leaves this right here. Do I have a little tiny piece of scrap? Yeah, I do. I got tons. That's gonna be a total mess if I just sink it in there. Do. Bangers, bangers all day. Bangers and mash. Is this Tales of the Inexpressible? I don't know which one this is. Hold on. I'll look it up in just a second here. Once I actually get solder to do solder things. It looks like a total mess, but it actually is good connections. It's just these round holes don't do me a whole lot of favors when it comes to protoing something. And I think next time we take on something like this, we should skip directly to circuit board just to show the viability of that. So I can say I've done both. Yeah, that's a ground connection. It's not great, but it is a connection. There are probably some ways I could clean it up, but we're prioritizing getting it done. So we'll get 12 volts from here, 3 volts from here, ground from here, negative 12 from here. Yeah, work first, pretty later. I can gussy it up later with a bunch of makeup. Let's put this down, and then let's cut our microcontroller spot. While the song has an absolute, I don't even know, has a party. Yeah, there it is. Oh, reverse alphabet style, huh? So we are between H and I. Bossa Nova, yeah. That's very... Between H and I. Man, psytrance is such a interesting musical genre. But you don't often get this. Schmongel is just... Simon Posford is just a fucking genius musically. Oh, god damn it. I can't believe I messed that up. Maybe it'll stick around. But the versatility of the psytrance beat is kind of crazy. I went all the trouble of having a straight edge in there, and I just freaking messed it up right away. Is he stupid? Then Raja Ram has to get his flute all over the album. Raja Ram is the flute player. This is, I can't believe how old this album is. Like, I was listening to this shit in college. In college. Again with my references, those Venture Brothers. Baron Underbite saying, in college, which for some reason is stuck in my brain. FK Productions, PHL, the dude who drops in my stream every now and then, and I'm very familiar with, we would listen to this music, and he's played it at festivals, and my muscles do not forgive me to this day for dancing as hard as I did. Look at the part I messed up is very minimized. I think these sounds are in there just for people doing acid, DMT, you know, whatever's messing up your perception, whatever's confusing your auditory experience with a visual experience. You put in little weird noises in the song, and then people respond to that. They're like, I see fairies. Oh my God. I'm freaking out. Amogus. Oh, did I do it too far? No, I did it not too far enough. There we go. Yeah, this is fine. Just like so. It's just confusing because of that overlap at the top. Seed Studios had to go with a rounded edge circuit board. Move. Oh, this song's Head Like a Frisbee, I think. If I get this crooked, my ancestors will never forgive me. I think that's decent. It's decent enough that I think their ghosts can rest. Got it in one. I know this time, all the lessons from yesterday, all the muscle memory and all the mistakes, all my regrets and thoughts and intentions and my soul being poured into this circuit. No, it's just we learned from yesterday. Oh, soldering iron turned off in the middle of soldering. It has a safety feature called IntelliHeat, which is not very intelligent, I'll tell you something. That turns on and off the soldering iron. Oh, those are a little crooked, aren't they? Oh well, that's where they're going. Oh well, LOL, LMAO. These things are kind of weird to solder. I need the big solder for this. I need the thicker solder. This stuff isn't allowing me to work quickly. Look at how far off that is. I can't correct it now. The only way I think I could do that is with hot air, and I think that's just too much trouble. Of course, doing it this way means I can't put any circuitry under the chip. If the chip was on standoffs, I could sneak stuff under it, but I can't do that here. I think we'll be able to get by, though. I don't think there's a total crazy amount of capacitors on this circuit. And most of the connections are straight thing to thing. I feel bad about my nephew having burnt his hand on the soldering iron here. He was we were doing some circuit stuff. I was teaching him how to solder. And he's young. He's like 7 or something now. But I was teaching him how to do the soldering iron and telling him, like, be really careful. This is super hot. Like, this is how we put, 2 wires together. This is how we do this. And towards the end, he loosened his grip on it a little bit, and it slid forward and gave him a little burn. And we treated the burn, and I told him, like, hey, oh, my brother's gonna kill me for this, but hey, you're being tough and all that. And so I guess somehow he construed that as he had to keep it a secret from his parents. And I'm like, listen, bud, if anyone ever tells you to keep a secret, like, tell your folks. Like, don't do that. Don't keep that. But I feel bad because he was like, I gotta be quiet about this, or Uncle Jesse's gonna get in trouble. And I'm like, no, man, don't worry about it. I need a T12 iron? Why? This is perfectly fine. I don't think you may not have seen the iron that I have and how amazingly functional this iron is. This is the Pace ADS 200. It is a professional soldering iron, and I can swap out the tips on it even faster than a TS200 or TS12 or the TS100. I have a TS100. It's in the closet. The tool chest. I don't know how they got R2D2 to perform on this song. But yeah, anyway, the TS100 it's a good iron. If you're looking for like a portable soldering iron, it's pretty damn good for what it is, and you can hack the firmware in order to have that little boost behind it. But this iron blows it out of the water completely. It does get, the TS100 does give this thing a run for its money. It's a very comparable soldering iron, especially when you consider that this is a $300 soldering iron. But this is a soldering system and station, and it's way better. All right, there we go. We are now exactly where the other circuit was yesterday. That's your intro. There's your intro. Whew, this thing's toasty. Like I said, if I'm not catering to chat and communicating absolutely everything that's going through my head, I can work pretty quickly. Yes, sir. Yes, sir. It's looking good. A little bit of overspray on the iron over here. Yep, cool. Now I got 2 of them. When you're soldering every day, when you're using a tool every day, you buy a better tool. You buy the fancy tool. This thing has changeable tips, so it works infinitely, and it heats up in 3 seconds. So it's a 300-watt soldering iron. It's got a lot to say. Okay, hi, everyone. I haven't looked up yet. I've had my head down. I need to get water. This is the problem with hyperfocus. This is the problem. I'm the warning. I'm warning you. Stay hydrated. Okay. I haven't even had caffeine today. I had 1 cup of coffee. Sometimes they are. Sometimes the professional tool is just like a slight redux of the amateur one, and that you feel robbed. I spent $300 on what? No offense, but you are a robot, aren't you? Dr. Pepper is actually oddly potent in terms of wake you up-age. I think there's a lot of caffeine in it or something. I gotta get rid of this fingernail. Nice soldering station. Hey, thank you. The reason that I know about it is that it was one of 2 that were used by the FBI's technical center, their technology center, and I went and bought one for myself. The other alternative was the Hakko station, which was way more, or not Hakko. The it was like a black obelisk looking soldering iron. I think it was a Japanese company, not Hakko, but that was way too expensive. And those quick change tips are like $15 each. So I decided to go along with that one. It was expensive, kind of sucked, but it is a permanent soldering iron. Like I've had this one for many, 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 many years. FBI's Jolt Cola. I remember Jolt. Is that still around? Is that any good? All right, big solder can go away. We're going to be doing a bit of surface mount stuff today. Bonk. And then where's the music? It's all the way over here. I love this album, but I must pause. Hello. Hi, hello. Oops, wait, I did the procedure. No. Okay, now we're back. Hey, my hair is too long, I'm a little disheveled, and I feel like I just woke up. But we are going to be working on soldering circuits today because it's raining out. And yeah, balls is disgusting. I hate that soda so much. My friends were way into it because early 2000s and being computer gamers, but it just tastes like candy and it's not worth it. I don't remember Jolt Cola though. I don't remember what it, I think it tasted like soda that had been like at the pizza place for too long, which you sometimes get when you order from a pizza place and their drinks cooler is like in the sun and the sodas just taste a bit like plastic. It's anyway, hi, we're still building 2 VCOs. I decided to take a break from the RC car because there was just too many numbers in my head, too much weirdness, and the generative design stuff was very complicated. It's actually, generative design is pretty easy to use. It's just that you have to assign forces for everything, and there wasn't a lot of room for like the body of the RC car, and I just kind of got distracted, and it's wet out, so whatever I make, I can't even test. So I decided that I would go with something that's a little bit more of like a locked into your shop during winter project and go back to the modular synthesizer for a stream or 2, and then maybe we'll do burn the subs and then get back to RC cars. I really do need to do burn the subs. I don't know why. I've got like a mental block on that. I'll have to do some soul searching and figure out why I've not been working on it. Maybe because everything else is so interesting. These are circuits from a YouTuber whose name is Hajiwo. If you want to check these out, Hajiwo, and man, he's coming out with new circuits like daily. It's like a weekly thing, but these are like simple modular synthesizer things that there's one that he did just recently that was all amplifiers, and it's just like a follower kind of thing. It's probably already up here, but he did a couple projects with the RP2040. The RP2040 is a microcontroller chip that's pretty damn powerful for what it is. It's a Raspberry Pi using MicroPython or whatever you want to use. It has integrated USB. It's like $1 a chip, so the boards that are built based on it are like a couple dollars, which makes for a really powerful digital system that you can utilize in order to create audio. And so I'm going to, for the digital side of the rack, build 2 of these circuits. One of them is just a voltage controlled oscillator. So you get a voltage in and you get waves out. And so whatever you can do with that, that's great. That's how you make the audio of your synthesizer. The other one I want to do is a chord VCO. So this one plays 3 notes, I think. It does just chords based on the voltages that you give it. So it's a voltage controlled oscillator doing chords. I think that's going to be very useful to give depth to some of the music that this thing eventually, that the synthesizer will eventually create. There it is. It's up in the corner. This is a washed out shot. Okay, well, anyway, I've needed a visual aid as I'm talking about various stuff. But yeah, the synthesizer's over there, and it's looking pretty neglected. I've had kind of a curse. I've had kind of a curse on me, and that is the curse of the analog troubleshooting circuits. These VCOs, I have 2 VCOs sitting here that are analog, and they don't work. And why don't they work? I don't know. I have to get deep into the troubleshooting of these things, and I barely even know how they work. That's the problem. In order to get them troubleshot and working, I really have to learn some of the concepts behind analog synthesis. You know, this one even has its own PCB, and yet it's completely like pants on head crazy for some reason. So I need to break my curse. I need to break my VCO curse, and we can do that with digital circuitry, because digital circuitry usually just works. You might have to tune it a little bit, but it works. Yeah, so that's the concept behind today. So what I've done is I've taken Hajiwo's circuit, this one, Hajiwo's circuit, and started to build it on perforated prototyping board. Actually, wait, this is all in the MS Paint file, because we've made some modifications. You see, Hajiwo does things cheap. That's the whole purpose of the circuits that he's making, is that they're cheap. Well, the purpose of my circuits are to have a functional VCO that I like, and that works nicely and does all the stuff it's supposed to do. So what I've done is I've decided to not leave the inputs up to Schottky diodes, or whatever type of diodes these are. I think they might be Zeners, but maybe they're Schottky. I looked up the part number and it said Schottky. So instead of having sort of like a protection here with Schottkys, somehow going, because this frightens me, is having on the same piece of wire, you have 10 volts and then you have a 3.3 volt circuit. That fills me with trepidation. I don't like that. These are supposed to bleed off any excess current, but then how does it even work? So a lot is over my head. Are you making a music machine? Yeah, the modular synthesizers are a way to get a bunch of functionality out of one single rack of equipment, and then you plug everything into each other using 1/8" headphone cables. So you have an 1/8" to an 1/8" mono cable, and you can plug whatever you want into whatever you want. The person designing the circuit needs to make sure that it doesn't explode with all of the voltage that you're giving it. So this is a 3-volt microcontroller, and the types of voltages you see in a modular synthesizer are typically around plus to minus up to 10. You know, sometimes you have triggers that can get a little bit worse than that, or sometimes you have like really hot CV signals, control voltage signals coming in. But basically the modular synthesizer controls things with gates and triggers, control voltages, and then audio. That's sort of the audio, and then audio filters. But there's 3 levels of signal, and that's control voltage, audio, and trigger. And those can take on a couple different characteristics, but they're all sort of within the same bounds. So we need to design for that. And the way that we do that is the MCP 6004 for an input to the microcontroller only runs off of 3 volts. So if you bias it correctly, if you bias the operational amplifier by the summation, or the equation of an operational amplifier depends on the input resistor and the feedback resistor. So this is 1/3 of the voltage, 100 to 300, and then this is actually affecting this reference 10 volts is affecting the level at this point with a bias on it. So that's sort of how this circuit is working. It's shifting everything, shifting the voltage levels, and then reducing it so that it fits within a 0 to 3 volt. And then since this is only fed 3 volts, it can only output 3.3 volts to the microcontroller, which would explode if any more voltage were present. So this is a big deal protection circuit. This really makes sure that whatever's coming in is represented on the number line. Whereas what this one is doing, it is doing a 1 to 3 biasing with a resistor. It's using a voltage divider. So the voltage comes in and it's got a 100K. It basically, usually they're like this. It's got a 100K, and then it's got a 33K, and then the summation, basically the amount that bleeds, the voltage that bleeds off. Because if you have a 100 and a 100, that would be a voltage divider that would make it half, I guess. So this does 1 to 3, but instead I'm putting an op amp in there. I appreciate what the op amp brings to the table. I think this is a more cromulent circuit. This one is cheap, very cheap, but I don't like that almost uninhibited. There's only a 100K resistor between your voltage in and 3 volts. I don't know. This also cure a little bit of ringing if the op amp decides to go a little weird. Then on the output, we have plus minus 12 volts on the op amps, but of course we are biasing them in order to get a third more. So this one could probably be 33, but it's 33 and 100K. Again, we're seeing the same numbers because we're trying to boost that signal up to where Eurorack audio exists. Eurorack audio goes plus minus like huge voltage. So RNG for the factory installed smoke. Yeah, I like you're one pinch of the tweezers away from blowing up your RP2040, which again, they're only a couple dollars, right? They're only a couple dollars, but you know, I don't want to resolder that whole thing. I don't know. Hajiwo's doing stuff in a weird way, and it's interesting. It's cool, and he's the ideas are flowing. He's making a lot of these circuits. So anyway, we're dealing with the hardware that I have. We're building for the hardware that I have, and making sure that everything works properly. It looks like they're doing a 5-volt output, but we're doing sort of a more. This is actually audio output from a mutables instrument module. I don't know what they're doing with the voltage level on that output. This is only what I've learned. You're also subject to the learning that I've had so far. This is another weird one. We're taking 5 volts into a unity gain operational amplifier. So we're reversing whatever's here, and we're giving it up to 5, it's not -5, it's 5 volts on the output here through a 10K ohm resistor. And so that 5 volts is applied to whatever control voltage input is coming in. And I guess it just biases it around. I hate that it uses 3 TLOs, or it uses 3 of the, I guess I'll have to get a TLO74 instead of a TLO72. This is just your like workhorse operational amplifier. Oh no, there's a 4th one, and they use that for this output. So this would be the input with, we may have to build this specific circuit because I don't think this CV input, well, I mean, what they're doing is they're changing that analog reference, but I don't know what that'll do down the line. And we're going to be putting in one of these little guys, these LM4040B10. It's a -10 volt reference, so it can handle a couple milliamps, and it'll basically be used by the comparators in order to do that bit of scaling in order to get this a plus minus 5 volt signal scaled on the number line and then reduced, and then it'll be 0 to 3.3 volts. So yeah, -5 to +5 comes in, and it gets shifted by -10, and that puts it, when it inverts through the amplifier, that puts it from 0 to 3.3. And we're taking 33% of the 10 volts. So all those numbers are in there. It's neat. What are we doing on Hajiwo's circuit? It looks like we've got some filtering, an LPF, a low-pass filter, which would be a lot of equations that I don't want to mess with. Low-pass filter for PWM noise. Oh, so we actually do need that. We actually do need that if we're going to have PWM noise. So let's go ahead and take it from here and apply our own circuit. What he's doing, what Hajiwo has, is a 5 volt op amp. 3.325. Whereas on our circuit, we're taking it to 10. I don't know if we need to change that around. If we do like a 2.7 and a 5.6. 39, 39. I'm looking at the numbers. So this would be half of 3 volts. So 0 to 3. This will be prudent for us to figure out what's going on in this area. So 3.3 divided by 2. No, oh wait, no, wait, we're feeding back all the way over through there. What does that mean? We've got, this is essentially a feedback resistor. No. 1/2 of that. Unity feedback. We're going into the positive. Okay, so we're going into the positive, but we're also feeding back a capacitor into here. I don't know what that's for. Audio op-amp circuit. Let's see if we can find an explanation. Oh wait, that was the window that I wanted. What is that part of the circuit doing? Hey, how's it going? Ah, there's a plastic bag in my way. Audio op-amp circuit. Let's see if we can find something that's doing some similar stuff. Because I would like to know what that thing is actually doing. It probably has to do with like filtering or something. I want to see whether or not we're building exactly Hajiwo's circuit, or if we can actually put those mutable instruments things into position on this one. The thing with the low pass filter was has me thinking. It has me thinking. Because we're doing various types of filtering going into this. Wait, hold on. Chat has fallen behind. Let's refresh my dashboard there. Okay, there we go. So now I can see everything again. And I got Smith Clay, right? Smith Clay, Dr. Plugger, Celia Russell, and then we're into yesterday. Thank you guys for subbing. Yeah, we're going to do a little bit of analysis on the circuit because I need to figure out what the hell's going on. And I think Hajiwo explained it. It's just that the explanation is translated from Japanese. So, 4 microcontroller AD converters, by adding the pot input and CV input, the lack of an AD converter is compensated for. Analog to digital converter, huh? 4 microcontroller analog to digital converters, adding the pot input and CV input. I don't know what that necessarily means. The op-amp immediately after the invert pot is a voltage follower to reset the effects of impedance. So that's a voltage follower. That's the mutables one. This one over here, would that be the low pass filter that he's talking about? That might be. Next operational amplifier is an inverting amplifier. Oh no, so we're talking about the inverting part. So that's not this circuit, this is the other one. This is the chord synthesizer. So what Hajiwo is saying is that this is to deal with the impedance. Immediately after the invert pot, that's this one. What is it? To reset the effects of impedance. Huh? Not sure I understand that. The next operational amplifier, that's this one, is an inverting amplifier. 10K, 10K. Amplification factor of 1, and the output is negative. So that's 10 and 10, so they're the same values, so they reduce to 1 in the math. And so then this one also reduces to 1. What the heck? Next amplifier is a positive output using an inversion genealogy circuit. So this is just an inverting op-amp. These two are performing basically the same task. It's just that what comes in here is inverted and then it's uninverted. Why did you do this? Next op-amp has positive output using inversion. Okay. Yeah, that's where we're here. And then it goes into his normal 2033. The subsequent 20k ohm and 33 ohm resistors convert 5 volt to 3.3. Ideally, we would use 22 kilo ohm instead of 20 ohm, but considering the influence of errors in the amplification factor of the resistor, we chose 20 kilo ohm, so that slightly higher voltage would be input to the microcontroller. This is why I prefer the mutables instrument design, because it on the input, it's just I don't know. This is better. It's better. It's just better. But that's all he explains. There's just this different adding circuit here for the input. And I guess it's biased by this. Huh. So, yeah, it's a control voltage or a fader. I don't know if I have that sort of circuit in here. Let's see where mutables does that. Let's see if we can grab a mutables that does that. I think there is one. I don't know if it's on... I think it's on braids, not marbles. I think braids has exactly what we're looking for. Let's check out braids. Or blinds? I forget which one it is. Bum, 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 bum. Let's see, where are we? We are looking for, here we go, braids. Braids is a module by Mutable Instruments. Emily Gillette has a particular way of doing things, and I like it because it's a good way of doing things. It's actually pretty cool. So I figure I am going to steal a bunch of these. So this would be adding the input from a knob, or, and I guess all of these are the same. They're biased to the negative 10 volt reference here through a 200K resistor. Well, that one just goes direct. What's the difference between these? Control voltage for FM and param 2 control voltage. These are using MCP 6004 and a TLO74. And they're all very similar to one another. It's just that one, this has a 200K there, and for some reason this one has it. This is just weird. It's just a little bit weird. This one has 120, and this would be pitch. 120, 100 coming from the CV into, oh, I see, there's two. Huh. Why there are two knobs? What are two knobs? Why are two knobs? This one doesn't have two knobs, and this one does it at 200K and 100K. So I think param 2 is probably where we want to be. That's weird that it's 0 to 2.5. I thought I calculated, on the other ones it was 0 to 3. Maybe some of the values can be tweaked a little bit here. So we get 0 to 3.3 volts instead of 0 to 2.5. What do any of these do? These all do 2.5 maximum. Why is that? Is the STM32 only good to 2.5 volts? This takes in 3. Grounded on V4 and above. I don't see anything to indicate. I have to look at the fine tune. I guess that's for the analog stuff. That's interesting. Oh my god, there are so many assignments of what the pin can do that they're running into each other in the middle of the schematic symbol. So yeah, I guess we'll take this one with only one adjustment on it, and that would be a bias adjustment. And it looks like the inversion is being done to the control voltage, but not the negative 10 source because it's already negative. Whereas Hajiwo has it coming from positive, so it's going into a different part of the circuit. If this were a positive 10 volt reference, we would put it in over here. But since it's negative, it does its job over on this side. I'm starting to learn. I'm starting to actually interpolate from the things that I've worked with in order to figure out what precisely is going on in these circuits. We used to do this with more digital stuff in an old job. That's not paint, that's paint. We're using paint as our primary CAD. So this one is actually going to get this circuit instead. And instead of param CV, this would be INV. I think these are just a little bit more advanced. Paint is indeed the best CAD. Bum, 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 bum. In spite of listening to an album that I've heard 10,000 times, my brain prefers Has Been Hotel musical music to the music that I've listened to for a long, long time. I don't know what is wrong with my stupid brain. Okay, so we got to build these circuits. We got to get signals from one board to the other. I need to put all this stuff together. I got my work cut out for me. Right now, what we have is power in and a microcontroller and nothing else. All the other in-between stuff needs to go here, and it needs to interface with the front panel over here. Now, the easier one to build is probably going to be the VCO right now, because this one has the added extra sort of biasing knob, the inv knob, whatever the hell that is. That's weird, though, because they both only have 3 inputs, right? I guess we're just sacrificing one of the CVs to be kind of a biasing knobby thing. Yeah, that's what it is. Okay, so this one gets, what does this one get? This one gets one amplifier, which we're doing, sorry, two MCPs, and then it gets two TL07 amplifiers. So we need an MCP 6002 and a TL072. And that's these two here, and then the other two over there. And that'll make one of our VCOs. The TL074, the TLO rather, is a, I don't know, it's a fairly clinical operational amplifier. The LM356, at least in terms of its handling of audio, gave me much warmer tones. I don't know, it's weird. I have opinions on op amps. Where's my life? Why is my life gone in this direction? Why do I have opinions on the different op amps? Jesus, I'm becoming the man my beard wants me to be. That's what's going on. I'm becoming a weird beard. Okay, so on the floor right now, I've got a TL072. I got in the mail my MCP 6002s, and I ordered 10 of them, and they came in Amazon Prime. And here they are. Those are not op amps. These are TIP 122s. These are like heavy signal switching transistors. Darlington arrays. So what the heck? Nate's are pretty okay. Hey, thank you. Twitch baby. Oh, are we at 9 months? We are indeed. Nate's, thank you for subbing. Hey, I appreciate you the occasional subs that you guys are rolling in. Thank you, Nate's are pretty okay. For the Twitch baby. We got a barber. Okay, let's see. So what I want to do is grab surface mount MCP 6002, and we will put that in the circuit. I can't do anything else. It's the through hole ones are just too far in the shipping array. So as such, I have been building a lot of these surface mount synthesizer circuits, and the next one we're going to make, we're going to design it for a PCB immediately instead of doing the perf board thing. MCP 6002 in smoke detectors used to amplify the signal from the sensor. Oh, I should go grab a smoke detector. I could grab the op amp out of it and we could use that. Let's see. Schottky diodes. No. One of y'all is going to be op amps sooner or later as the stack gets taller and taller. Here we go. Op amps. Oh, really? They're the MCP? So I'll have to get more smoke detectors. Why would they use that particular chip? Strange. Multiple smoke detectors. Because you know when they're using a TLO, or sorry, an MCP 6000, when they use a single op amp chip, you know that they only have one. If it was a 4, you might also get like a 2 banger, or maybe an additional, maybe they need 5 op amps. 6002. SO8. Anything below SO8 is impossible to work with unless you're designing it on a computer. But with SO8, we can actually still solder decently to one. It's just a little bit more work. What do we build first? I guess I'm building the output circuit first, since I'm grabbing... No, these are the CV inputs. I'm doing the CV inputs first. And then we've got to figure out where the inputs are coming from once I lay out the circuit. But we will have 2 op amps on this part of the board. And one will just be... I mean, they'll both have the same footprint. And I actually do have PCB things, little breakout boards, but those are more for breadboarding with the surface mount components. So in this case, what I'm going to do is just tape down the chip, well, glue the chip to tape, and then I will do the wiring around that. Let's see, since everything is relatively spread out on this board, I guess I'm just going to choose a spot and go from there. I really don't have a plan. I don't have any idea of what I'm doing, except that we've compiled the schematics that we're going to use. And this is all the space that I have to work with. This is going to go on top of the front panel board. on the front panel board, we could run 3 volts out to this thing and put the switch. Well, the switches are, what are the switches doing? Really should have pull downs on the switches, but it looks like he just connects them directly. So we're just connecting, oh, I see, because they have pull ups. So these will be input pull up, where the microcontroller can flip on a resistor that goes to positive power. And that way, when this is flipped off of ground, when it's in neutral, in a neutral position, then, oh, are these 3-way? Wait a second. I might have the wrong kind of switches. He's got 3 contacts on these things. I don't have, hold on, let's just check. Let's check what the design has. That means that I need to order switches as well. Holy crap. Every project, man. It's like this one looked like it was perfectly like easy to do, but then it ends up using a whole bunch of like parts that I just don't have. Like center on, off, on switches. I don't have those. Where did you go? Why are you hiding from me? Get back here. Okay, there's the circuit. That's one of them. This is the other one. 53rd module. Frequency, modulation. That one's in center position. God damn it. Fuck. What is the setting then? Fold FM and AM. Damn it. Okay, we need a part. I need a part. I need an emergency part that I don't have. And that's going to change the design of the backing board too. Ah. Oh, that's annoying. Oh, that's very annoying. Well, we'll still piece together the op-amp part of the circuit, and I'm going to do an emergency order of switches. On, off, on, panel, mount. Really? Toggle. And I need the kind that aren't enormous. This is actually the number that I would need to do both of these synthesizers and then nothing else. On, off, on, guitar, mini toggle switches. Let's put mini in there. I hate it when a project does this. It has me do this trickle, the slow feed of 10,000 parts. On, off, on. For car and boat. And it's got boots. I don't want booties. I don't want little booties. I'd rather get more switches. Or less switches for less money. Okay, here we go. Purchased other variations 3 times. Yeah. I know. I know I have. I know. All right, let's bring this over here and we're going to order it. Buy now. All right, so whatever. I'll have those tomorrow and I'll have to redo the backing boards, but we can at least make progress on the front of the board today. I can't believe that little detail is something that I just noticed, that there are 3 dots. The schematic symbol for a switch is a dot, 2 dots, and a little lever, because originally when people were actually, you know, building circuits on breadboards, the switches were these like knife switches where you have just like a brass pivot on one end, and that was one of your contacts, and then the other one went into a brass like clip that would hold on to the thing, and you know, sparks would fly and everybody would ooh and ah, and the lights would dim, but whatever. That's what they used to be. They used to be like physical things. And so when you would have multiple switches, you draw 2 of those knifey things, and you draw a dotted line to symbolize that they were connected to one another. In this case, you know, that's brought switches all the way to the modern era, but now you do the dots, and if you have a dot in the middle like this, that means you have 3 positions. So an on-off-on switch will have 3 contacts, not 4, and that center contact is just represented by nothing is connected. So it will sever itself from everything and park itself in that position. We can't get to that position. We can't put a wire on it. We can only put a wire on the one side or the other side. And then if it was a DPST, instead of a single pole, single throw, we would have a dotted line between them. But yeah, 3-state toggle switch. I missed that entire detail, which puts me back a little bit. But all right, it's okay. We don't. Basically, what we're doing right now is I'm putting these to headers. These will go to headers, and then I'll redo the front panel ones, and we'll do it to Much to my chagrin. All right, so what are we doing? 0134. So I'm going to need to see that pinout on the RP2040. What's this window? Oh, it's more of this information. Oh my god. This is the bad pinout. This is the one that I didn't really understand. There we go. Neat little chip. It's very cheap, very powerful. 32-bit, or what's it running at a frequency of like 100 and something or other? 133 maybe? This thing's a beast. I don't know if it has an antenna on it. I don't think it does. Okay, so let's build the circuit for the ins and outs. That's the next part. And then we need to build the -10 reference. And we can hook all that stuff up together, and hopefully we'll get there in the end. Where are we? Okay, sorry, just so many windows open. This has gotten ridiculous. I'm not doing a Saturday because I need to upload. I need to upload more video. More of my e-waste needs to be spread throughout the realm. All right, we don't need this anymore. And then we've got... The one thing that I'm worried about is whether or not the RP2040 can handle the input circuits that we're going to be giving it. These are... What is it? It was 0 to... Where's the circuit? This one says it's 0 to 2.5. So that's going to get in our way. That's going to keep us from having the full spread of CVs. We'll have to see what it is. Maybe we could get the RP2040 to tell us what it is. Or we could just put a multimeter on it. Okay, let's build the circuit. So I'm going to need to... Let's see, our inputs are there. We're going to need resistors. And I'm going to need to put down this MCP 6002. So let's get to that. Let's get to that. Oh, it's over here. Here's a chip. And we need Captain tape, but not the big kind. I need a slightly smaller thing of tape so that I can glue down our little buddy here. And we're going to what pin? P26 and P28. P26 and P28, what side of the microcontroller are they on? P26, P28. Okay, so we're on the left side of this thing. So we're over here. So I'm going to put this over here. And that should help. Something, I don't know. The way that I'm going to make this, the way that I'm going to build this is by using wire wrap wire, and I will be dropping them down below to go to where they need to go, because that'll put it in between the standoffs on the end. Standoffs on the end will interface with the front panel PCB, so it'll go together as a little PCB sandwich with a bunch of wire wrap wires in between. Conceptually, something like this, but not really, because it won't be quite that much of a bird's nest. When I get a little bit better of an understanding of how that VCO is supposed to work, I would like to get my grubby nubbins in there and figure out exactly why it's not working properly, because I get a clock signal for the Bic and Tic, but I'm not getting the VCO to do anything. And it could be a matter of tuning, but I don't know anything about what's going on in there. And it's all hardcore analog circuitry, which is tough to troubleshoot. But that'll be some good scope time if I can figure out what exactly I want to do there. I want to leave a little bit of room for the circuit, but I also want to make sure that I'm not crowding out where I'm going to put the -10 volt reference. If we go here, well, it would be more like this would be probably the better way to do it. Although that's a little close. That's a little danger close fire on the connections on the ends. Yeah, that's not really going to work. If I do it like... I mean, that's probably the way to do it, is like that. Yeah, like this. Or no, wait, didn't I do it some way that I can anchor down? Yeah, that's what it is. It goes like this, and that way we've got 2 of the pins out here, and then we've got 1, 2, 3, and 4 holding it down. So basically, we just need to block off 3 pins. What a waste of Captain Tape! What an incredible waste of Captain Tape I've put into service here. Let's move it towards the micro a little bit. We'll do these 3 right here. Actually, yeah, these 3 right here. Tape is cheap. Tape is cheap. Time is money. Oh, it's a little close. I'm disappointed in my cutting. All right, come on. Yep. Okay, so now we solder one of the corners in order to hold the chip down. Now, where am I putting pin 1 on this thing? This wasn't really bending? It's fine. It's fine. Did I have a data sheet open for this already? I don't think I did. Although we were looking up... Nah. Well, the MCP 6002. Data chart. (6002) SOIC, pin 8 VDD, pin 4 VSS, and VDD is positive voltage. So plus and minus 12 on there. Those are going to have to be wires, and then our 2 op amps are like that. The MCP is going into, so we'll do pin 1 towards the microcontroller. Noticeable one on a microscope, yeah. The blade can take a little bit of beating. It's not that bad. They do eventually snap because they're hardened, but they can take a little bit. All right, so I want the dot to be facing towards the microcontroller, just because that's where the outputs are. And then I'll solder the corners down. Need my small solder. I'm used to these being top only holes. These are vias, which is a little overkill for a prototyping board. I like the top surface only ones, but my source for those went away. Some chat member found where I could buy like a bunch of them for not too expensive, and I did, and then I lost the link. But I used to use square top surface only holes. These are plated through in the vernacular. Where is this? Come back here. Why are you going all weird on me? Why are you going all weird on me? The problem with the plated through ones is that they suck the solder down, and then it becomes like a bubble at the underneath, and that makes it hard for me to do stuff like this, where I'm trying to get the solder to stick to a pin leg. Not a big deal if you're using all through hole, which is what I was going to do, but they sent me the wrong parts. I'm not even going to return it. I think the TIP 122s are probably worth a little bit more. Little Darlington arrays. Yeah, this is sitting above a little bit, which is not helping me make contact. What is going on? What was that song and dance that we just did? Is that sticking up? A little bit. We'll tamp it down with a pair of tweezers. I should stop using my fingers. I'm gonna burn myself. He's totally burnt. Okay, so there's that. So let's get the other legs of this thing soldered down. And we'll start wiring up the connective stuff. All the connecting tissue. Okay, so that's our first op amp down. Now we need to figure out the circuit that surrounds it. So what that'll look like is this. So we have our input going into the negative with a 100K. I'm not going to do the ESD thing. I have these, I have a bunch of these, and I could put them in, but this is not that kind of thing. If this were a direct replica of a mutable instrument module and it's worth like $300, this is not. This is a $6 thing, so. The dark side of the circuit board. 200K, 100K. Input to negative. One of them comes from a ref. So those are inputs. Those are going to go over on this side. And let's find my resistors. Now, I probably shouldn't have done it this... Actually, you know what? Instead of using the big resistors, let's use 0603s. If we use 0603s, that means I can get them from the book. We go to the library. Dun, 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 dun. That's these folders over here. These things are really handy, these sample books. So I've got 0603 resistors, which take up quite a bit of space. It's kind of big. And then I've got capacitors. Bada bing. It makes it much easier to find the values. I actually used those surface mount bins to organize all of my 0805 resistors, and it takes up a ridiculous amount of space. It's not worth doing. Now, the way that these op amps are arranged in the chip, it means that we can put resistors across leads in order to create connections. So what I'll be able to do is, in order to do the feedback, I need pins 1 and 2 to have a 33 kilo ohm resistor across them, which when you're dealing with 0603 size, that can be done pin to pin almost. I think it can be done pin to pin. So pin 1 and 2. Sorry, I keep going to the wrong scene. There's the right scene. Pins 1 and 2 over here can be connected together, and then pin 1 is the output that'll go into the input on the micro. So a 33 kilo ohm resistor, I could move that upwards or downwards, because the other end of that 33 is going to have to go to a 100K that'll take it to the input, and then this third pin here goes to ground. So that should go like over there. Pin 4 is connected to what? It'd be very convenient if pin 4 was in fact. This is how we improvise, by the way. Pin 4 is VSS, which in this case is ground. So those two can connect together. Perfect. All right, now we're rolling. Okay, so back to the microscope. This is why I get paralyzed when I play games like factory games. We've done factory games on stream before, easily. They're very fun, but I get totally paralyzed by having to optimize everything. So this will just go right here. And actually, where is ground? This is ground over here. I don't think sometimes I will run ground directly along like the pins, but I think what we need to do is probably get ground from elsewhere, and that'll free up some of this stuff. It'll free up some of the circuit stuff so that I can lay things out. That's not quite right. Oh, come on. Things just aren't moving the way I'd like them to. Problem is, when I go to solder that, all of that's going to solder all at once. It's all going to become molten, so it's going to try to run away with the soldering iron. It's going to try to leave due to surface tension. Oh, maybe it didn't. Didn't do it this time. That's kind of nice. Try to move this down a little bit. Damn it, the whole thing just left. Ah. Work with me here a little bit, please. All right, let me get the tweezers. That'll make it a little easier to wrangle this thing. Bend that back. Oh, doesn't really bend back much. Come on, man. There we go. Repeating this on the other side is going to be a little bit more difficult. Maybe that's where I get it from, because this pin also has to... Oh, wait, no. It's this pin, I think, that has to also go to ground. Let's check the other side of the circuit. Where is the plus lead? Or sorry, the plus lead goes to where? I need to reference my master drawing. Plus goes to ground. Plus goes to ground. So I can do pin 5, VSS, and pin 3. So 3, 4, and 5 are all going to ground. Okay, so that's a bigger piece of wire. Okay, that's much easier. That's much easier than what I'm trying to do here. Much, much easier. Okay, so let's just take that away. Get this little piece out of here. Come on. Out. You come with me. You're under arrest. Okay, there. So instead of that, what I can do is I can go to this pin. There. And then I'll take that and I'll put the pin tool down on it. And then we'll just cut that. Okay, and then this book is in the way. Get out of here, book. I need like a circular bookshelf to surround me when I'm working on stuff like this, because all the things just pile up. I didn't have to use glue on this because all the pins are the four surrounding pins are actually anchoring this thing down, which is good. I like to not use super glue on everything. I'm gonna add solder to this because it's not cooperating with me. Looks a little janky, but it'll be okay. You kind of have to embrace the jank after a certain amount. This could probably move just a little bit further out. Oh, but it wanted to move in. That was a little weird. Yeah, whatever. Good enough. So that's our ground line. How's that look? Yeah, it looks okay. All right, ground line is there. So then we have 33 kilo ohm on the other side here. And that also gets a capacitor, although the capacitor is not totally important for us to have. It's there to reduce ringing. 27, 33. Oh, the only problem with using the same exact stuff as mutable instruments is that I've already used a lot of the stuff for mutable instruments. I have been building these circuits out of these exact parts, so I'm very low on my stock of 33K. That's okay though, we only need 2. I could always put 3 100Ks in series. Would it be 2? No, I think it's 3. Okay, let's see here. I need a little bit of solder down in order to anchor this. But I think if I'm going to be putting that capacitor in there, what is the value of the capacitor? Let's see if we can get the caps out too. The value of the capacitor, 470 picofarad. It's a very tiny capacitor, both in stature and in value. Those are the resistors. 470p. Let's see here. These are from Murata. What do we got? 0603, 50 volt. Where's the value? 33p. A little bit higher than that. 150, 160. Those would probably work just the same. 390, 470. Here we go. Let's get 2 of these. These are equally teeny tiny. There we go. So we need to put both of these in parallel to those pins. Oh, and I lost. No, here we go. We're right here. We are right here. 4747. Go. I could do them both. Well, I could also do them out here and then connect them with a little piece of wire, or I could put them directly up against it and put them out this way. Just like 1, 2. I think I'd rather have it here because I still need to run the input over to it. So I could do both of them out here, and then I can run 2 wires. One will be the output to the microcontroller, and the other one will be the input from whatever. The input from the, actually from the pin header that's going to go out here. So one wire will go like this, and the other one will go like to here, and then jump under the board and go to whichever one of the pins that it needs to go to. That's a much better way to do it. All right, cool. So that means I need to fill that one with solder so that I can anchor these parts down. Tombstoned, which is where the surface mount resistor goes directly vertical due to surface tension. Oh, okay, that's fine. That's fine because I'm going to reuse the pad for both of y'all. Sometimes you can impart enough heat that the pad on the opposite end of your connection goes molten, and then your parts start spinning around. There we go. That's exactly what I wanted. All right. Let's see. Actually, our input comes from a 100K and a 200K. So I'm going to need a 100 and a 200 that lead to there. I may have to move one out and away. I probably should have done this a little bit more towards the center. If I'd done both of these in the center in line, it probably would have given me plenty of room to work. Oh well. So 100K and a 200K, because the outer row I'm reserving for the pin header that's going to hold the 2 boards together. Let's go over on this side and do this one then. We're doing these 2 in the middle. How's that going to work? I guess I'll do it in a similar fashion, because if I keep the front area clear, then I can come in with 12 volts from there, or 3 volts from there. So that means a bunch of things. Those 2, I guess I can go diagonal, and I can use these the symmetrical holes on the other side. So we'll go here. All things considered, I should probably not hook these up to the microcontroller yet. in case, because we might need to like tune them to get good outputs, or at least to know what the outputs are. I may have to go into the code and change some of the behavior of the code in order to cater for the changes in circuit design. Some things invert, some things don't, etc., etc. That, and then you come with me. Ah! There you go. How did that work out? That shouldn't have worked out. Now in this one, I can put the 100K there and then the 200K next to it. So let's get those out. Where am I going to want the... Because if I need to do 2 resistors on this from 2 different locations, maybe one can go diagonal and the other... Yeah, I think that's how it has to go. And then I'll have to jump over to there and then up. Okay, cool. I have a plan. I have a plan. I'm probably running out of 100 and 200s. Yes, I'm completely out of 100 kilo ohm resistors in this. Okay. What about 200s? 200s, I've got some. This is why I subscribe to Prime, chat. This is why I do that. Amazon Prime is a vital tool because if I'm out of 100K resistors, I'm going to order some more right now, and I'm going to be totally disorganized about it. 100K 0603. Have I already ordered? I may have already ordered like a whole thing of 100K 0603s. I might have already done this. $5 for how many? 100. Yeah, okay. $5 for 100. Buy now. 1% tolerance, 1/10 of a watt. Yeah, that's all the good stuff. Gimme. That's $6 I'll never see again. You paid $6. You paid way too much. Yeah, well, it gets here tomorrow. Straw man. Straw Mannington, if that's her real name. Okay, so the other thing I want to do is just make sure that I don't have a whole thing of 100 kilo ohm resistors that are 0603. Because if I ran out, one would surmise, one would think that my next step would be to instantly order more. I don't really see anything hanging out around the places where I'd stash new parts, so I guess that's not the case. So let's go 0805. Which means taking these out. This is the next size up. The next size up from 0603. Which I have in these giant ass containers over here. They're way too big. 100K is right here. These things would be a total disaster if I dropped them. Because when you drop these bins, they all open up. The shock is enough. $100K. That's a pretty healthy amount. I'll get 2 of them so they match, so they don't piss me off. Eye twitching. Tweezers? They're right here. So this will be the one that goes crossways, I suppose. I could do the same thing with both of them and have one go straight over and the other one go crooked. Yeah, I guess I could do that. Okay, so I probably need to revise that wire then. No, that actually will work. That will work. So that'll go like that, and I'll actually do the same thing over here just to keep them symmetric. both sides looking like they're doing what they're supposed to. Because yeah, I'll have just a piece of wire go bop, bop, and then actually bop, bop, and then another one goes bop and output. It's nice to have a plan. Everyone has a plan until they're punched in the face. Okay, that didn't solder. Yeah, these are kind of annoying to work with surface mount on, just because gravity is pulling all the solder all the way down and out. What is going... Okay, flux is causing this to stick to the tweezers, which means I can't grab more solder to add to this because I don't have enough hands. And then for some reason, soldering iron seems to be failing to really kind of flow that. So it's like half-assing it. It's really weird. What just happened? I think maybe it was that I didn't put enough solder down because I'm not cognizant of the fact that I need to fill the via, and then it's gonna bubble downwards when I do. Which I need more specialized surface mount proto boarding, because yeah, that's a weird connection. All right, 200K. Well, actually, let me do the other diagonal one first. Let's go on like this, because that'll go doot, doot. Or no, doot, doot. No, that's, yeah, so it goes between these two. So that'll have to go yoink. I could have used probably should have used, I have these surface mount breakout PCBs that have all of the op-amp structure on them. So you can just follow, you can just put the resistors in the spaces that they go. They take up a little bit of room though. One day I'll use those, one day. That, nice and diagonal. Nice 45-degree part. Yeah, the Fat and I were talking about this in my Discord, and making a PCB for this project wouldn't have been good because we're approaching the Chinese New Year. So if I didn't submit it quickly, it could get delayed for a week or two. Luckily, making the circuit boards is so fast nowadays, so I'll probably have to bolster up a collection of parts. This is ridiculous. This is just no. It looks like there's not enough solder on anything. I really dislike using these boards for surface mount, I guess. Look at that, all that solder that was right in the right place, and it just went and went below deck. If we look at it from the other end, there's a nice big bubble of solder. Ridiculous. I guess I could put tape on this side of the board and then it would hold the solder up. Luckily I don't have a big piece of Captain tape just sitting right here. Let me do that actually. I'll just shove a piece of tape on where I'm doing the surface mount stuff and see if that helps. Our ins and outs will be figured out a little later on when we get to wiring. But for now, I want to put all the little circuit elements in place and use surface mount for that. So we'll just cover the board in a piece of tape. Because yeah, gravity is starting to really get on my nerves here. Let's use the big stuff, the big wide stuff that I got out. What? Oh, that's totally cursed. Well, we'll use this piece. Ah! That scared me. All right, that'll make things a little bit more pleasant for the time being. It's like, not quite. There we go. Okay, so 200 kilo ohms. I think those should be the smaller ones, just because we've been kind of consistent. Classic. Yeah, it always scares me when it falls like that. I wish I had one of those vices that had the little like lip at the top where the circuit board could like nestle in. Then that wouldn't be a problem, but no, here I am. We want 200K. 200K. There you go. And as is typical, I'm missing a ton of them. You know, you could do it with different resistors. I don't know why 100 and 200 were chosen for this. I could do 220 and then 120. Probably what I should do. Or maybe less. I could go, what, 90? What? Oh, wait. Is it 91K? Are you kidding me? That's a weird value. Well, whatever. 50-25. So as long as the ratio is preserved. All right. Now solder this thing down. My hair is getting to be kind of a big problem. Oh, these aren't numeric values. These are the weird coded values. So 30D is somehow 200K. One of them, the other one. Got to put my finger on the board in order to hold up the soldering iron. That's a lot more pleasant than the other ones that I did. I have a wire, but I was prepared. Okay, let's see. Get that. Get my... Let's get a little closer with this camera. You guys don't need to see my belly. You guys need to look at my belly. Just enough to see hand positions. There we go. Hopefully my hands don't block everything. I may have to do a higher angle if that's the case. I should name all of these angles so that they could be referred to as my techniques later in time. Yeah, this is the bother funky angle number 7. I want to keep this circuit out of this area. Actually, it's pretty much taken over this area. It looks like the TL072 is going to have to exist down here, and then I'll have to figure out where that analog reference is going to go. If I did the TL072 surface mount, I guess that, maybe we could do that. I wanted to use through hole on this, because that's like the type of circuit that it is. Why don't I get to do what I want? Okay, so this is connecting to here. Here to here. Actually, here. Hear ye. And then here to here. Wait, is that right? That's... Yeah, because this is power, and then this one is the positive side of the op amp on this side. So then it would be negative and then out. So out goes up here. Okay. I have a plan. I found using this big soldering iron, even with the little surface mount, is very useful because it's just able to blast heat into everything that you're about to solder. The small tips kind of struggle sometimes, although the needle tip might be good for this particular joint. Oh, the iron's turned itself off. The needle tip might give me a little bit more precision here. I think I'm about to... Yeah, I'm going to switch to the needle tip. Let's give that a bit more of a shot here. It's either the needle or this one. This one was usually my workhorse. But when I was building those other circuits, you never knew when the designer of the circuit board gave too large of a ground plane and made it so that you couldn't get the solder to flow. But I think actually in this case using my slightly blunt needle tip is the way to do it. All right, ready? Time to soldering. Ready to solder. Let's clean that a little bit. Clean the tip, clean the tip. Okay. So I'm coming in here, going to this pin. All right. Oh yeah, that feels way more intentional and precise. And then I'm taking this and I'm going in here. And over to here. And then I'm severing my ties with this wire. One day I'll have the knife upside down and blood will just go shooting out. There we go. I just cover this whole mess with solder and pretend it never existed. No one will be the wiser. The worst part is that when I'm working really hard and I'm like, you know, really focused at what I'm doing, the knife will end up on the table under my hand, like under my wrist even. And it's like, bro, if you move just a little bit wrong, you're going to be in a world of uncomfortable situations. Explain that to the ER doctor. All right, so that doesn't look soldered. I assure you that it is. We do the same thing with this pin, so it'll go doot doot. Doot doot. Let me get solder on that pin. Which one is it? Yeah, it's on. I don't know, I think I may have to go surface mount with the other one in order to make it work in the size that we're working in. Okay, that's soldered. This is going, I shouldn't say it, but this is going very smoothly so far. Having now said what I did, is when everything will go wrong. It's all going to go wrong. What can also happen with this is that I'm soldering such small lengths of wire that the whole wire will carry the heat, and then it'll end up loosing itself and coming away with a soldering iron. It's not that big of a deal, but it does happen at this scale. Go. Just make sure this one flows over completely. There we go. All right, that's that part of the connection. And the outputs would be, I guess, carried on wires, but it would be from this point and that point, that point and that point. So I guess I'll solder, yeah, I guess I'll solder a tiny length of wire in between them just to be sure. Usually I'd include it with the wire that carries the signal away, but that's going to be a wire, so. Whenever I do streams of this stuff, I always get the Worthy Kids Eye of the Wire song stuck in my head. Is it Eye of the Wire? I forget what it's called. It's the one with the clowns and the vampires animation thing. This is a real sort of hard song. All right, let's see. Very Death Gripsy. Right. And then that's not how that one goes. This one has to go like this. So that's kind of a difficult one. Let's get in there. Let's do it. I'm ready. I made many an accursed circuit like this in my day for various reasons. I never thought that building stuff like this would be obsolete, because it is. It's just really weird that it is. Due to cheap circuit boards. Cheapy cheapy. Super cheapy. You're looking at a dying art. Of course, all these techniques are the techniques that you would use to get your first draft of the circuit board working, because the most important thing to do when you are making a circuit board is get the first draft to work by any means. And that means scraping up pads, that means doing little bodge wire connections like what I'm doing here, anything to get that circuit to work. Anything. Okay. We got our 4 inputs. 2 of them come from AREF -10. We have another entire amplifier that needs to go down, and then I need to build the AREF -10. I feel like this area right here should be where the AREF -10 goes. If this is our complete input circuit, what else? Okay, hold on. Let's just make sure. Yeah, it's pretty much everything, except for the connector, which is on another board. So those are input circuits now built, and those 200 kilo ohm resistors are going to have to get AREF -10. They're some of the only things to get AREF -10 on this board. We're building the singular VCO right now. We're not building the one that has chords. This is the chord VCO over here, and we have sort of an alternative circuit for this part, which means that we would need, well, we've got 1, so we've got 3, huh? Oh yeah, Paint is of course our schematic program here, and we are lifting with much love all of the circuitry from Emily Gillette, who is the builder of the mutable instruments modules, which are really, really good. And she has, throughout her career, refined and refined and refined sort of these input and output designs to 3-volt microcontrollers, which is why I immediately went to these designs, because we've got an RP2040. That thing is only compatible with 3 volts, so we use these circuits, and then that gives us just, like, you know, much more expensive sounding module electronics. Okay. So 330 ohms, we need a 100 nanofarad capacitor, and then we need the LM4040. Now, I have a bunch of LM4040s because I just got through a whole odyssey of building a whole bunch of mutable instruments modules. So the LM4040, I'm going to get from down here. I reorganized all these, so all my voltage references are together, all of, you know, all these little parts that you accumulate when you're building all kinds of different weird circuits. Because you ask 2 engineers to do something, right? 2 engineers to solve a problem. They will come up with 2 wholly different ways to do it that will solve that problem. And so that exists in electronics when you're not just using ASICs. Like if you have a problem that requires more than 1 ASIC, then you run into that thing. Even with 1 ASIC, you can see by the design whether or not two engineers have followed the same set of instructions, or if they were free to come up with the solution to a problem in the same way. If I were to do all this stuff from scratch, I would probably have slightly different values in all my resistors. 24.9K is of a particular specificity that I don't understand in this circuit. I don't know why 24.9K is the solution to that question. But through testing, I guess, you know, the other design was vetted out. Oh, these aren't the right ones. Wait a minute. Wrong one. Hold on. Wrong one. Wrong one. Keep looking. My hair is starting to get around my glasses and tickle my face. Those are those FET drivers. They barely exist. They're so small. Oh, never mind. Those are totally different. That's not the right one. This is the one. These are gate drivers. They're 4-pin devices. You can see the 4 pins. They're so small. That's not the one. I would love to hack the Omnipod insulin pump chips, because I have the ability to have quite a few since I go through one every couple days. It seemed like something we might be able to take an attempt at. These are not... Yeah, those aren't right. Birch. We were just looking at this one. Nope. Other direction. There we go. LM4040 BIM -10. So those are negative 10 volt references. So I need one of these. I'll probably need another one later, but for now, we'll just grab one. They put it in an SOT23, which makes it a little weird, a little confusing. And then the TLO72 is our other big chip to go in here. I was just looking at op amps. Where were those op amps? Quad SBDT. Maxim part. Here's the op amps. I guess I'm going to need... what am I going to need for the other circuit? Hold on a second. Let's just... We're not going to work on the other circuit yet, but I'm going to need one MCP 6004. And then if the input... What's going on? I just saw something move. I think I'm just going crazy. Yeah, 6004 TLO74. And then the input, this is an input. That's one of the inputs. The other input is just going to use the other MCP 6002. So that's two MCP 6000. Well, that's one MCP 6002 and an extra TLO74. Let's see here. So we got two of the TLO74s. Three? How many are used on the output? Wait a minute. No, the output is a TLO74. Oh my God, my brain hurts. Okay, let's see. Hold on, my brain is itchy. I have two different circuits here. I think this one is biased a little differently. 0 to 2.5. 0 to 2.5. Why are these different? 100, 100, 24.9, 24.9, 24.9 there. In between them, 49.9. This one uses 24.9 here. And then that's biased at 120K, whereas this one's at 200K. I wish there was more explanation in the circuits. So in order to build this circuit, I have one 6004, and the other one will be used on the other channel in the way that we're doing it right now. So that's one 6002. In terms of TLO74s, I have one there, and I think that's it. That's all that I'm using. One there, and then on the output, I've got two more. So 6004 would be in order for the other circuit. Okay. Or sorry, a TLO74. So I need a TLO74, a TLO72, an MCP 6000. Hold on. There you go. Oh my God. Okay, okay. So one of these for the input. TLO72. I know, oh God, I have a lot of these. One of these for the input, or sorry, for the output of that one. And then I need a 4. That's TSSOP. These are useless. Unless I'm designing my own. I don't have a TLO74 in surface mount, do I? singular, dual, dual, dual quad. Oh, here we go. Nope, that's TSSOP. There's the SO14. Okay, so these are the ones that I'm using. Actually, the SO14 is probably going to be very difficult for me to solder around just because of the way the pins are organized. Might be better for me just to use 2 of these. That makes the circuit easier to build on my end. Doot. And a doot. Well, if I have a TLO71, I don't think I have that. All right, so those are all the chip parts that I'm going to need going forward. Take a glass of water. I only grabbed one of the AREFs. I'll have to grab another one later. Okay, so here's this part. This I would like to be near the power supply since it is just another power thing. I can put it on the other side of the board, I guess, but I don't know how much room this thing is going to take up. And I can't use the outer row. And this circuit is going to look like... Well, the circuit only has one in and one out. At least we got that going. Right here. That's what that's going to look like. That's a lot of parts. Mm-mm-mm. 39, 39, 100 pico. Got a little feedback. Jiminy Jam. Okay. That's a pretty complicated piece of circuit. I like how my zoom levels are too far out and then too far in. Just between those two. I guess I could have moved that one up a little bit, but I do like to have a little bit of room around things. So if I do, my 3 volts is over here. That means positive 12 is over here. This circuit for this piece is connected to what voltage? VEE and ground? What is VEE on the Emily Gillette circuit? Amelia. 1.5 milliamp. This is AREF minus 10. And here we have a 1 kilo ohm, and that's going to VEE, which is minus 12. So we need to go between minus 12. Okay. VEE and VCC, like whoever's building the circuit can call it whatever they want. I need to verify that it's what I think it is. So this is actually going to go on the under part of the circuit. It's going to go under the circuit with the other power supply stuff. Yeah, you go right there. And so I'll flip this over. Oh, wait. Careful. Flip it over. And now we are on the underside of the circuit, and all of our negative stuff is all the way down here. How small can we make it? We need something like a resistor on it, in which case this one has a 1K, and then it has a 470 NF cap on it. So let's find the capacitor, and then let's also look up the LM4040, because I have no idea what any of these pins are on this thing. I don't know what any of this stuff is. And we'll have to peel up my little solder guard. I'm hoping that we can just like stuff it over here, but I don't know if that's actually going to be a reality. Oh, it goes between ground and VEE. So that's these 2 pins right here. So maybe we can cram it right up against it, just like right here. But let's look up the outputs of this thing. So LM4040. Still not a browser window. LM4040 has something under my, that's just a piece of solder. Doesn't matter which one it is. Although, well, we should probably look at the -10. It's probably going to be a big multi, wow, there's a lot of, we'll just look up LM4040 for the 3 volt. They're probably going to share, that's a computer model. Hold on, nope. Improved precision micro power shunt voltage reference with multiple reverse breakdown voltages. Boop, 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 bop. Yeah, here's the different types. A, B, C, and D, and then voltage types too. All the way down here, we're looking for our little pinout. Usually it'd be at the top of the data sheet, but I guess it's not. I hate it when they don't do this visually. I like it when they show you what the circuit looks like. They just draw the symbol inside of it. Positive terminal of the shunt reference, negative terminal of the shunt reference. The dog just started to go woo, woo, woo at the door. Shunt load, I shunt. But we're talking negative here, so what does that mean? Does that mean our positive and negative are going to the positive and negative? It'd be anode and cathode, I guess, plus and minus. Anode A plus, C minus. In this case, anode plus is going to VEE, and minus is going to ground. And there's 100 nano on this one. There was a 470 on the other one. It makes you wonder which one is correct. A 330 ohm instead of a 1K. Whereas the application circuit tells us, well, it just says RS. There's probably an equation then involved with it. Huh. Do they show the reverse anywhere? I don't think they show the negative. That's tricky because, like, I bet you the connection for the negative source is mentioned somewhere in the data sheet. But if you're looking pictorially like I do, you're wondering, like, wait, what the heck? But ground is above -12. So this whole thing is reversed. But then they put the resistor on the other side. What is the typical application in terms of... There may be an application note that you can reference in order to see the negative voltages, but like if I was doing this, I would miss those details and get that totally wrong, and then sparks would fly. But here we are finding the details that we need to catch. This is a later design than the other schematic that we were looking at. This one right here. The design that we're looking at in the browser is an earlier design, but it also has audio out, which is why we pulled it up. That would be one of these. One of these ones that we reference. Actually, wait, the non-inverted one is the later design. Or sorry, the Fusion 360 one is the later design. This is the later design. So 1K and 470 nanofarads are the values that we're going to use. $1K, 470. I'm doing this because these notes are going to sit in the folder with everything else. So if I ever feel like building another one of these things, I can reference it. So yeah, let's get to building. That's how we do it. We reference the schematic, we figure out what our next steps are going to be, and then we gather the parts and put them all together. 470 ohms. I'm in the wrong book. This ain't my book. 470 nano. I wish we came up with another delineation for capacitors, something that was a little less confusing than these nano, pico, and normal farads. And 1 NFs are a little weird. 470 pico. Wait, 470 nano. Ah! 470N. There we go. Looks like I've used a lot of them. A lot of them are gone. They've gone the way of the noble gases. Yeah. And a 1K. I use the smaller ones. We're trying to make this small. I should probably hook up the other board with its -10 reference as well. because that's sort of standard kit for both of these VCO units. That's 11K. What am I doing? What am I doing? Oh boy, supplies are low. 1K is a very common resistor type. God, it's been a rainy like month. It's been raining all month. Everything here is a swamp, completely inundated with water. All the snow's melting and it's raining at the same time, so it's water everywhere. And then tomorrow, I gotta give my doggy a bath. So she's just gonna be soaked. She's such a thick undercoat that when I give her a bath, it's like a most of the day kind of affair. She'll go and sit by the front door, but she'll still be pretty wet underneath. And I use a hairdryer on her, but it's not powerful enough. So anode and cathode, positive and then negative if the pin is on the right. And we have positive and negative. It's juxtaposed to the direction of these two. That's very annoying. That is so annoying. So if I put it like out here, it would be proper. But it needs to be after that. Like it goes like this. Oh, that's so annoying. I should have put the power plug on the other side. What, let me double check this. Positive. Yeah, it goes, okay. Oh, that's so annoying. Plus, minus. That would have been so good because I could have just put it on the end here. Although it needs the 1K resistor to go through it before it hits positive. So with the, hold on, with the diode there, it would look like, yeah, because it looks like, like this. Okay, so that's what it looks like there. And then I've got a 1K and then a 100, say 470N going in between these two. And then the 100 here goes to negative 12 volts. Wait, so actually no, it is, so if I do flip it, it's fine. Double check with the datasheet. I don't ever trust myself on this stuff. NC, positive, negative, and positive goes to negative 12. Okay, wait a minute. That is correct. Nice. Okay, so then it is flipped. It is flipped. I have flipped. Let's get this out of the way. You get out of my way. And this goes like, I guess there is a little plus sign on it, huh? Like that, and then I've got 1K here and 470 there, and then this is my VREF. So if I do diagonal 1K, of course then I have to get negative 12 out of here some way. So I guess leaving that for my exit, having that there and that there. Yeah, okay, so that's our reference, huh? So first we'll put in this. Quiet day. I guess chat doesn't have much to interact with because I'm deep into the project. Hey, what up, Brink GG? Good to have you. We're having a quiet day where Bother figures out exactly how to put together a circuit. You got an ad. Oh, great. Has Twitch started to break their own ad blocking system just out of spite? Why is this not soldering in? Why are you not cooperating? Oh, solved with a refresh. Actually, I could do it. Oh yeah, no, the reason that I'm not doing it like that is because then it's hard to get to. I need to be able to get to -12 for the TLS74. Yeah. Well, they're both companies are doing that. They're both trying to get you to not do ads anymore. Or sorry, to not block ads anymore. My brain doesn't work so good. Yeah, I could pack this in really tight, but then I wouldn't be able to get the voltage out of it. Yeah, we're still working on the RP2040 modules. For the intro to stream, I actually built the second board, and I built the second front panel board off camera, realizing that the switches are supposed to be on, off, on switches. So I had to buy a couple new switches and have those. Those will get here tomorrow. So unfortunately, I'm not going to be able to finish this thing until Tuesday. But we've got a lot of work to do, and we're going to get through most of the build here. And then on Tuesday, I will finally have a W and have a couple of these modules done, and hopefully get ahead of my uploading. I really dislike these circuit boards for doing surface mount, because all of the solder wicks down because of gravity, and then I end up not having the thing fully soldered in. It's very frustrating. It's very strange and frustrating. So what we're trying to do is get a -10 volt reference, and the positive pin on this thing goes towards, wait a second. No, the positive pin goes towards VEE. So this is not the right direction. That's the positive pin right there. And so that would be the pointer of the diode symbol. And then the other one is the, why is this tape encroaching? Get out of here. Why are you bothering me? Go away. God. Well, if I solder it in upside down, I could put it in like this. Wait, is this marked on both sides? I think it is. It's got markings on both sides. That's kind of cute. It's got a little plus sign on this side. Cute. Oh, I think those are way too high up for me to do it this way. All I need is for these two. I'm going to do this like sideways. Because yeah, the positive, wait, no, positive goes towards VEE. Wait a second. Ad block would be a non-issue if they didn't want to throw 3 ads to start every 30 seconds and then only, yeah, or if YouTube actually like vetted out their ads so that they had ads that make sense. Is this wrong? Wait a minute. Why am I having so much trouble with this pinout? Not connected, positive, negative. And in the grand scheme of things, the way that this thing is hooked up, negative is hooked up. See, they don't show you any context for the symbol that they use. I guess I have context here. What I can do is I can go to the board itself and find the LM4040 in this mess, which it is right here. LM4040 B10. I don't know why that's marked as VCC. Ground and then AREF -10. So ground is on the upper pin. And in the schematic, so this is positive. This is negative. What the heck? That's so weird. They didn't, like, normally a diode you have, like, for instance, an LED. This is the anode. This is the cathode. Plus, minus, right? That's an LED. So where do they get off using a Schottky or Zener diode or whatever symbol, and then putting the anode and the cathode, although it's not an anode and cathode, it's different, but it's, why are they putting them on opposite sides that there should be? That's so weird. But yeah, the AREF minus 10 is coming from minus 12, and this thing is shunting out 2 volts. So it's VEE going through a resistor, and then having the other capacitor in parallel. Well, actually, wait a minute. That one goes to ground. Yeah, okay. But does the... wait a minute. Wait a minute. I could still be getting confused. AREF minus 10 is that pin. So that pin, so if I flip the thing around flat, and it goes, it actually... yeah, it is reversed. Okay. I don't know if the stuff I wrote about the thing, I don't know about this stuff is right, but tap spoons in your head to solve hearing problems. Yeah, there was a weird one that I got recently that was totally scammy. I don't remember all the details because I tried to get out of it as soon as possible. I don't want to give them 1 second of my day. Right. So it is opposite to the way this thing is. So that resistor coming in goes to this pin. And then this one goes to... but this is ground. Okay, so this needs to go over here to VEE. So the resistor needs to change its tune. And then this becomes negative 10 VREF. But I also don't have any room to work in here, so I actually need to move this over here. This will go here, and then we'll move this over to here. That way I have this pin right here to grab negative 12, because otherwise I would be getting into the edge row, and I'm not supposed to get into the edge row. The edge row is for attaching the 2 boards together. This thing ended up taking up a lot of space for being such a small circuit. Okay, capacitor, what are you doing? Why are you being a weirdo? Okay, so now this goes in that way. I could just like throw it on top and just have it sit like that. And then that needs a wire that goes all the way back, or maybe like sneak it in like this and then just go around. That ain't gonna work. Nope. No, it shall not. Also, this thing's upside down. I mean, it could also work if I put it upside down over here. That would mean, actually no, that doesn't do anything, does it? Flipped around? Yeah, like this actually, right? Hold on. Man, I keep getting in my own way on this one. So that one is going to ground if this thing faces the other direction. So this thing faces like this. And then that pin goes to ground. Top pin. Top pin to ground. Bottom pin to the resistor to VEE. Is there any other way that I could do this that would make it... I have to put it in over here, but then I wouldn't have the diode in there. Flip it upside down and put it over on this side. That's the only way that it works. So I do this. And that's upside down right now. You can even stand it up a little bit. Highly unprofessional. Also can't get to it because of the tweezers. Is that really acceptable? We're really gonna do things this way? Yep. I consider myself as having no choice. Come on, fix yourself. Break yourself. Here. Well, it's cursed, but it is definitely installed in the circuit. I just need a wire to go up to ground. Where'd that wire go that I was using? I think it fell on the ground. Yeah, I lost it. I think it fell in between, yeah, my legs and the table. There it is. That's not it. There it is. That's not it. It's plastic. What the hell? What is that? All right, I'm getting a new piece. Means I gotta get under this huge pile of stuff. Oh boy, that's a lot of stuff. Nice piece of red wire. And then we're going, oh boy, straight across there, which is gonna look real bad. If I had anywhere to pick up on that -12, then it would have been a lot cleaner. But we're just trying to get the circuit down here so we can move on, you know? Oh, damn it. Moved. I wonder if through-hole would have been a little bit more organized. Certainly a circuit board would have been way more organized. I'm constantly struggling with the idea that perhaps I'm wasting my time and I could be putting this into CAD and design just a handy-dandy little circuit board with all the stuff on it that's needed and go ahead and just batch order 5 of them. Oh, this stuff isn't flowing. It needs to be tinned a little bit. Once I get the whole wire in there, I'll be able to come back and tin it. Tin it in it. Yeah. All right. And then cut this just a little bit further, like right there. I almost lost the board is starting to collapse into the vise. Dun dun dun. Fuck. That's when that happens. Well, those little shelves on the vise that'll hold this. Whoa, that was a bin falling over. Luckily there weren't the sounds of 10,000 parts scattering on the floor. That would have been the real fun part of that noise. All right, so it's not great. It's not great out here, but it is in and it is connected properly so that the pin that goes to ground, and the pin that goes to VREF goes to VEE through a resistor, and it's got a capacitor in parallel going to ground. So not my best work, but it is functional, and we need to do it to the other circuit actually. We need to do it to the other board because it is a primary component in this. So anyone who went and got a cup of coffee and then came back is going to be very confused at what I am doing right now. Like, wait, didn't we just do this? I didn't get a second set of parts because I'm dumb. So let's get a second set here. These are different values. I need to get another LM4040. Where are those? Here, let's go to this view. Oops, that's not the right view. That's the right view. Lin receiver. Nope. Where do these parts always go? Where do they always run off to? Oh, here we go. So LM4040, I don't want the 2.5, I don't want the 5, I want 10 volt. And then I want a resistor and capacitor. So we need a 1K. This is a 1K, right? I think it's 1K. Oh my God, there's so few. '0603 is a pretty comfortable size. I think I might want to move much of my operation over to 0603. 0805 is what I used to use, but I think these are just small enough that you can still read the value on them, and they're still manipulatable when you put them down. 470N. Let's bring it up, bring it up, bring it up. Up. I gotta get burn the subs working again. My numbers are terrible. Actually, they're pretty good today. You guys are awesome. You're watching the slow burn of an engineering stream. We gotta get burn the subs up again and do a little bit of make stuff move, you know? Make things move around on screen. That's the key, I think. A little bit of this, a little bit of that, you know? Ah! Instead, we're laying down parts with a technique that is as obsolete as the streamer. We could be using Fusion 360. Bring back Fartbox? Yeah, that's going to be a little bit of a project, but it'll come back and it'll pave the way for furthering burn the subs. Where did my LM4040 go? There it is. Because having the Fartbox on Node Red is going to be a big improvement. Will be a big improvement. How's it going, Turts? Turts McGurts. Oh my Turts. This wire out of the way. All right, so this goes between negative there. Of course, all that solder gets sucked into the via. Which leaves this high and dry. It means that I have a much harder time soldering this part on, which is strange. It's very annoying. Stuffing a burrito into the face. Nice, nice. Nice, nice. I had a hoagie. Where did my resistor go? Did it stick to my... It must have stuck to my palm. Somewhere over here there is a resistor, and it might be on my hand right now. There's a 1 kilo ohm chip resistor that walked. Where it went, I do not know. I didn't feel it on my hand. Hand's sensitive enough to feel something like that. There it is. Do you know how I saw it? Because it looks like this. Oop, I missed. You got to kind of recalibrate what you think is your ability to, I don't know. You got to think, you got to really like rethink what sizes are of things. Like you look at it on the microscope and it looks absolutely enormous. But when you actually look at it IRL, it's the size of a grain. It's smaller than a grain of rice. It messes with you. You get messed up. I need to find a supplier of restaurant tortillas, not the crappy, you know, white bread supermarket fajita night burrito. I mean like the real deal. And I don't know what kind of markets there are around. Does a farmer's market have good tortillas? Like, I gotta find the good ones, the ones where you can load them up with a whole bunch of stuff and it like stretches all over the place. Those are good. Those flour tortillas for the supermarket are only good if you toast the tortilla, and I'm often too lazy to do that. Oh, damn it. You get down. I know a lot of people press their own, but I don't think I've got that in me. Rob a Chipotle. Yeah, really. That may be key. Okay, and then we take the LM4040 and we put it in the most accursed manner possible. I don't know why they decided to make it like non-symmetrical with this stupid package, but I'm putting it in upside down intentionally so that the right leads get to the right places. And then I'm also tilting it so that that actually touches the board. These are things we can do when we do it like this. Although if I install this on the other side, then that's actually pretty good. Yeah, I can install it right side up here. Hold on a minute. I just solved everything. And I can have the pin facing, well, no, I have to have the pin facing away. The pin has to be in this direction. But I can install it up here, right here. Genius! That's why the second revision is where you do all your good stuff. Although I could have... No, it has to be like this. It has to be right side up on this side of the board. And I can just sneak that in like that. What up, Kirvos? Didn't melt that? No. I think I'm good. N2M, I don't know what that... Not too much. Okay, there we go. The new Wonka movie. I didn't even hear about that. I heard it's like bombing pretty bad. Calvin, I lived. I love that meme where the guy texts, "I lived, bitch." He's from the hospital. Okay, there. We're going to do that to the other one because this is just marginally less cursed. And that way, what pin is which on this? This is the positive pin going to ground and the negative pin going to -12. And that shunts away 2 volts. Away with you, 2 volts. Okay, let's do the wires on this one and then we'll go and fix the other one. Were you in Ohio or something, Haystack? Is that why you say you lived? Skibbity, Ohio? You survived the Rizzler? Fellow kids. All right. That's terrible. The worst. I probably could have moved this all. Oh, no, I'm not moving it up because this is where I need to pick up on -12. Oh, you survived the work week. That's right. Happy Friday, everybody. You're already done? I don't have any alcohol. You know what? I gotta be sober tonight. I was thinking like, hey, I could celebrate the end of the work week, and who am I kidding? I have so much to do. I have to upload videos. I'm like Rob Oz now. Permanently uploading videos. The VOD channel is gonna have a video a day for a long time. And they've got no traction, no monetization. I'm not getting anything out of it. It's purely for archival purposes. I got like 2 new viewers from doing, what, 150 videos daily so far? Oh my God, those numbers. He'll be famous in no time. Yeah, so I don't know. I don't know what I'm doing out here, chat. I thought today was Thursday again. Yeah, we're doing double Thursday this week. Sorry, everybody. We're doing double. We're doubling up on Thursday. We figure we're just not going to have a Friday. Let's do this here. Come on, baby. There we go. Very weird stack of electronics that I've created here. Would you just solder the wire? There you go. Okay, so now both of these circuits have their -10 reference voltage. And that is simply going to go to, I think the MPC 6004, just to bias the input and protect it against stuff. Let me flip over to the other circuit and move the MCP from here to the top layer. Tekken 8 came out today. Huh? $100 Canadian. Well, at least you're not buying it in Australia. Australia is ridiculous with game prices. How is Tekken these days? I haven't played a fighting game in a long time. We used to do fighting games for group hangout time. I was very good at Soul Calibur 2 and 3. I would play as Cervantes, and I memorized the sequence of buttons that I had to hit in order to do the corkscrew move, and then the move where Cervantes catches you on his knife gun and knifes you and guns you and then throws you down. And if I did that in just the right spot towards the edge, it was the most disrespectful combo of moves that you could possibly ever do. You corkscrew at them and then pop them up in the air, catch them on the knife gun knife, you knife them and gun them, and then toss them out like garbage over the edge. And I did it to FK Productions PHL one time, and he was very, very salty about it, and everybody was cheering and clapping. And then I found $20 on the ground. Just right on the ground? Yep, $20. You always add that to a story that's a little kind of boring. If you don't get a reaction that you want out of the crowd, you go, and then I found $10 on the ground, and they go, wait, what? What? You what? You found $10 just right on the ground? Where? Was it like, was it? And all of a sudden everybody's super interested. You wait, you what? Hold on, wait. I'll have 3 for its custom character making. That sounds like a win. It was, I didn't mean to make my friend so salty. But they were much better at the fighting games than I was. I just sat down and memorized that combo because it was so disrespectful. All right, so there's our MCP 6004. Our -10 voltage reference is, I think, on that pin. No, it's on that pin. Because yeah, 1 kilo ohm goes to the outer part from -12 volts. -12 volts is right here. So the TL072 gets -12 volts. The MPC 6004 gets that reference voltage. No, it doesn't. It gets ground and power. So that's coming from over here, the 3 volts and ground. So the TL072 gets all of those fancy powers. So yeah, that's over here. So we'll just place this, I guess, in the middle of this spot. So we'll just put it right here. So these 3 right here, and hopefully we will be able to build this thing properly. I mean, should we move it over a little bit? Well, if it's on the same 3 as this one, the circuit's gonna be a little bit different. So let's move it over 1 row and do 1, 2, 3, and then that'll kind of encroach on this stuff. But this stuff goes to wires anyway. These, this one and this one go to the -10 reference. So those go here. That'll just be something that we have to figure out. Low kick. Yeah, see, the thing is, like, as salty as he got, he was one of those people that would do that. He would corner you in the most unfair way. He knew how to do it. He didn't do it all the time, but it's still. Those guys were much better than I was. I was doing everything I could to survive. It was survival. I didn't do anything wrong. I was a product of my environment. Ruthful. That's a new one. Ruthless, brutal, uncompromising environment. I deserve to be rehabbed instead of living with my guilt. He was very salty. I guess I would be too. Should I put it in the exact same spot? Now we'll move it over one. This is like an ongoing puzzle. This is a continual. Actually, if I don't move it over, it's going to be cramped up against that. So it would be nice if I had room over here, or if I had just centered the entire design. That would have been a better idea. Just centering the whole design, and that way I would have had room on either end to build my proper circuit. They are very naturally restricted, though. Oh, wait. Yeah, those are the same ones. Yeah, okay. So it's going to be approximately the same amount of BS to deal with. I have very little room to make this, too. So, TL072, let's look up the pinout, and I'll get that. Well, if we have them both facing the same direction, I guess the ins and the outs are going out this way. I kind of wish it was one of those days where FK actually like drops in on us. Sometimes he'll do that, he'll drop in. This really should have been done in the center, and then this one could have been off-center a little bit. I'm not going to revamp the whole thing because I don't need to, but just having all this blank space over here. The other circuit is going to have 3 of these chips, so I'm probably going to do 1, 2, 3, and it'll be even more squished in. But this is what happens when you ad-lib it. I thought I would have space around this thing, but it turns out this should have been right smack dab in the center. It could have been moved forward 1 row, and then I would have had a blank row behind that, and then this would have had room to breathe. It would have been like behind it over here and had just plenty of room on either end. But oh well, here we are. And then you could probably design this on an actual circuit board and leave room for various technologies. So you could actually have several different circuit layouts that would be associated with the ins and outs of the RP2040 based on its other circuits, based on the other circuit designs. Does this have tape under it? It does now. Yeah, if I took like 3 or 4 of the designs that use the RP2040 from Hajiwo, I could get 5 boards made and then make 1 of each of the 3, and have, you know, multiple parts down on the PCB that wouldn't necessarily, you'd have like an A, B, and a C design all on the same board. And I guess board houses try to charge more for that, which is a little funny. Oh, you're doing 3 designs on 1 board? We need money for all of them. You're not allowed to do that. They're so, like, possessive. Did you put 4 designs on this board? You can't do that. But yeah, I could have done a board that has multiple unpopulated parts in order to make it the different things. I love those boards that we looked at that one night, one day when we were looking at topor routing. Topor routing is where you just put the traces to what they need to connect to next. You do it as rudimentarily as possible, and all your traces are just like weird cursed paths. Because mostly, especially in stuff like this, a lot of the circuit trace designs are just for aesthetic. They're just for aesthetics. They're just there so that you can find them. They make logical sense in producing the connection that you want to make, and they look okay. They don't have to be. We're not high speed enough to need certain types of like circuit structures and the grounding and stuff. I'm actually having fun watching the prototyping. As many schools and home hobbyists these days have those PCB CNC machines. Yeah, PCB CNC is really not necessary. Like I'm telling you that, and until these services like all die or something, right now the meta, the way to do this is to actually go to a PCB manufacturing house, because it's just end to end. They put FR4 on one end and a whole goddamn PCB comes out the other. And they do this for $5 a board. They auto panelize it and everything. Everything is automated. And so you spend $25 because you got shipping, and then you get circuit boards in a week. I should have done that with this, because that would have been so much easier. We will do that with the next thing that I decide to build in this manner. These circuits are pretty cool. There are a couple that I would like to just build like this as well, because they use just like a couple TLO74s. There's like a follower circuit that I want to build that should be pretty cool. But yeah, the board houses, like, the trouble of buying a CNC mill to make a PCB, it's totally unnecessary. It's going to be too expensive. Even if you DIY it and you make a pretty good one, your vias are something that you have to put in there. Like, I mean, I guess you could do the plating equipment, you could plate it through, but the vias, like when you build a CNC circuit board, have to be like riveted in. You have to insert them in. I saw the lady doing this when I was working for the Bureau. She put all the vias in there and they had to be like expanded in, and then the quality of the circuit board is not going to even like approach an actual board house that has that amazing machine that just poops out circuit boards. So, you know, I think all those methods are dead, including this one. They're just dead. They're dead. They were killed by machines. And as a result, we have a very easy design process where you can jump straight to surface mount. But the techniques that go into building these boards also foster the production of good PCBs that work. Like when you get that prototype in, you have to make it work, because you will find multiple problems. Still ferric fluid and a laser printer. You know, it's not laser. You understand that? Light amplification Z of simulated emissive radiation or whatever. Simulated. Let's see here. What does this look like? I don't know what that last word is. Hold on, let's look up the TLO72, as much as I should have memorized the pinout here. Yeah, by simulated emission of radiation. TLO72. TLO72. TLO72H. Okay. Hey, by the way, there's a new version. We put an H in the name. Scroll, scroll, scroll. Looking for the pinout. Scroll, scroll, scroll. That's a weird one. I've never seen that. That's for the single one. I really hate when they don't draw the thing inside of the chip. Let's just do TLO pinout. I like it when they draw the... Okay, it's all headphones. Oh, I put an 8 in there. There, I like that. That's so much nicer for me. And then our circuit is going to look like... not that. That's for the other one. We're doing this one up here. That is our circuit. Atrocious phone talks to text for the win. Yeah, that's a tough one. I always find I'm way too verbose when I do phone to text, and so my text messages are like enormous paragraphs. So 100 picofarad, 10 micro, 39K, 39K. This is coming from... Oh yeah, and we still need that square wave filter. P2 is... Where are we? P2 is the second pin up on the right side. Okay, good. That uses the right side of the thing. I mean, you know, maybe we could have done... If I flipped these 90 degrees, then this could have been here, that could have been here. No, I think I would still be having the same problems. This is going to get weird. Okay, so P2 is this pin right here. So what I'm going to do is take that pin on the other side. So now we're over here. and P2 is this right here. So it's on F row, and we can take it from F row, and we can make that filter. At least the plated through holes let me do that. And then we've got a piece of Kapton tape under this chip, so we won't solder to any of the unintended things like the USB connections. And that's 220 ohm resistors. So let's get 2 of those. And we'll get the capacitors. Wire all that up to ground. Is it 220 ohm? Let's double check. I'm only using one monitor. I should be using, it's 220 ohm. I should be using all 3, and then I would be able to have parts and the microscope and the schematic in 3 different things to look at. This is where multi-monitor setups really come in handy. So what this is going to be is just a little filter that's going to turn, it's going to eliminate those little bits of square waviness that the microcontroller's DAC puts into the wave signals. Just going to smooth it out just a little bit. Sometimes you don't want that in there. Sometimes you want it to be a little crunchy, but not in this case. And then the capacitor that I'm going to need is a 10 nanofarad. Turn your tomes to paragraph 12, page 72. Ohm. 50, no. Yeah, 10 NF. 10 NF. 10 NF. That would be these. Wow, these are, I'm finding that these are the values that I'm using a lot to build these synthesizers. Seems like there's a lot of commonality in these parts. Damn it. Need to get that other one out, but there's like a plastic membrane under this stuff. It doesn't peel as easily. Where are my tweezers? Tweezers will help with this. The tweezers will help for this. For this. They don't help at all. They're quite useless. There's like a waxy, like whatever the adhesive is that's holding the plastic tape to the paper tape is disintegrated or turned into some kind of like a plastic, and it doesn't give up. It's like a waxy plastic. Disgusting. 10 NF, put that back. That's probably why these were cut up and put into little sample books, because the big reels were the big orders of parts, and then the little samples are what was peeled off. So we have this sort of like a low-pass filter. There's a couple different structures of filters that you can do with resistors and capacitors, and my entire exposure to them has been academically. So resistor, capacitor, filter types. And they just have, mathematically, they have different effects on the stuff that's going through. So you can have, you know, R and C just like this, and you can do a high pass and a low pass filter, or you can do different like RC, band stops, all kinds of cool stuff. And sometimes they're expressed in springs. The whole spring. No, those aren't actually, well, those are 2 springs. Those are 2 coils. Okay. This was all Circuits 101 stuff that we did, and that class was at 8 o'clock in the morning, and I did not retain a single goddamn thing that it said. We had this whole workbook that we went through in order to buff out our Circuits 1 stuff and get all the math in one place, and I wish I had kept that book, because there's a lot of good reference material in there. But yeah, there's all kinds of stuff you could do with just RC if you're a super math nerd, but you know, I don't know nothing about nothing. I don't know nothing about nothing. So what are you even doing here? Let's see. We got this going in. So I need the two 220s in line with P2, and then I need two 10 NFs coming off of it. Where is ground on this RP2040? Where anything is anything? It's all the way up here, and we are going in D2, or P2 rather. P2, and then ground is up here. So that is pretty accessible. We might be able to actually get to ground. Although I may have wires going directly to these and going down to their voltages, so that might be another thing. And then some of the P's have to go over to the front panel. Okay, so let's build this filter. First jump is directly from the pin, and I think since these are a little bit overlapping, I think I have to go from back here, because there's solder on this pin. That means that both of these are connected. So I'm going to go here first. Should use a big solder for these. We'll keep it with a little solder. Keep it with a little solder. I think they were the same weight in solder, so... Oh, the solder actually didn't fall into the pin. I really don't want my ground connections to block everything over here, because we do have to do quite a few connections on this. Are those actually connected? They seem like they're not, because I'm not soldering, like I'm not heating it. That stuff falls through there. Maybe it just can't work its way through. Those two should be the same thing. I got this giant solder blob sitting up top. It's not letting go of this. I got flux all over my tweezers after working for this long. Right. I'm not going to build this structured any differently. It doesn't have to look like the filter. Nah, there's no real... I don't have any real good recourse. These are very simple passives, so I'll just build it to look like the low-pass filter. Oh, great. Thank you. Thank you for tipping over in the absolute most inane way onto your face instead of... See, the black band on this is actually the resistive material. The white is the substrate. It's a copper substrate for the chip resistor material that's painted on top. And then it's got two little end caps that are solderable and a value printed on it. All right. Then this one goes right up to it. See, Hajibo actually built his circuit, part of the circuit, underneath the headers that the RP2040 was on, because he put it on standoff headers, and that way there was a little room underneath where he could put a couple capacitors and stuff. Since we're doing surface mount, we put it right up against the pins here, and we have the underside where we can do pretty much the same thing, just a little bit different. If I was designing a circuit board for this, though, this would all go on one circuit board. All the controls, all the diodes and capacitors and all that stuff, all of it would go on one circuit board. There'd be plenty of room for everything too. The design of these circuits are kind of interesting because it's like, it's all digital, right? So you only have this type of structure on the ins and outs. You have your stock filters and you have your stock input, swinging stuff. So like the MPC circuit versus the TL072 and 4 circuits are all the same for the ins and outs, depending on how many you have. And then the controls are easy as it goes. It's literally just a voltage divider that goes between positive and negative, whatever the input to the microcontroller is. Why did that desolder itself? That was really obnoxious. It's very annoying. It's very annoying. That's not soldered. Okay. And then ground is a couple pins above it. So it's P2, P3, P4. Sorry, P4, P3, 3 volts, ground. So if I do that, I'll get that over there. 3 volts, of course, we're going to be getting from the other side of the board. So that'll be a longer wire that I have to install. Sometimes this wire just doesn't like the solder. It's really annoying. All right, you know, try my hardest. Doing my best. Oh, that's why my iron's dirty. Gotta clean. I just use a dry brass, whatever, not Brillo, but whatever the, what are the other ones called? I forgot what it's called. Scotch-Brite. No, not Scotch-Brite. Scotch-Brite is not the right thing. This is what I'm talking about with this solder. Like falls with these pins. I add a little bit of solder to it, and it happens to look like it's a good connection, but then when I go to work with it, all the solder falls in, and it becomes like a divot. Ridiculous. Let's see. The top one is 5 volts, and the one below that is ground. Oops. Whoa. Let that cut. So going like that. You know, that might not be connected. I should probably put a little piece of wire on that. Oops. Come on, buddy. I'm having so much trouble with the heat. I guess that pin is... Look at that. It's the coldest joint I've ever seen. It's freezing cold. A cold solder joint is when you have a break in the joint and the thing that you're trying to bond, like the pad and the pin, can be separated. It doesn't have to be separatable, but that crack being there means that there can be an intermittent connection, and it's sort of it's a thing that happens when you don't get enough heat into the thing that you're soldering. You see here how as the heat settles in, everything kind of flows into itself, and it creates that wet look. So being between cold and wet is typically where we function. Which is odd because cold and wet is not juxtaposed. My dog is viciously barking at something outside, and I hope whatever it is out there has learned its lesson, because she is mad. All right, I'm gonna put a little piece of wire on that upper one. I never get to see her during streams anymore. Maybe during the summer she'll hang out a little bit more, because typically I keep it cold down here, and she does not like heat. As a Welsh dog, she does not like heat. Or cold, or wet. No, actually, I think she really likes the cold, because she was running around like a madman out there with her friends. So I think she really enjoys the colder weather that we're having. It's not that cold today, it's just kind of like wintry bleh, but all makes a difference. In the mood of my dog, which is very important to me. All right, that is our band pass, or no, that's not a band pass. What is that? Hold on. I gotta look at the notes. What are you? That's a low pass filter. So from the low pass filter, we go to the input of our first op amp. Okay, 39K. 39K, and then through another 39K ladder kind of thing. And that has 100 picofarad over to the pin that is the output on that side. Let's do that 39K over by our filter. And we'll do it out this way. Where is our TLO going? It's going, well, that's the RPi. That's encroached over there. That's our TLO. So it's going in this area. We do not have a lot of room. So we're going to try to offload some components here. So I'm going to put the 39 kilo ohm right here. Let's get that out. Open your books to page, let's see, 39K, 390. 39K, there it is. Hey, look at you. 24.9K we're going to have to build out of other parts. Then, of course, we got to see whether or not we did the right thing, because the RP2040 is not an STM32. But the STM32 goes from 0 to 3v3. The notes in the documentation for this thing say 0 to 2.5, which is a little weird. That's half of the range. Well, not half. It's more than half of the range, but it is avoiding 3.3. So the values might need to be altered a little bit. You can see how much slower this is than what I was doing during the beginning of stream, which was replicating the work that we had done on the other circuit. These circuits have many, many parallels between them, the chord VCO and the normal VCO. And so I've kind of built the two in parallel up until now. Of course, I'm going to need to put 3 of these chips on the other one, so I don't know how that's going to work out. All right, so from there, we are going to the input of the op amp. Well, we're going through another filter, a 39K and 100 pico. Another 39 and 100 pico. Boy, this circuit is sloppy. Sloppy. If I'd planned out the structure of this a little bit better, it'd probably be in good shape. Oh well. 5, 6, and 7 are where we can build this part of the input of the circuit and then do the output up here, and that way we will be going into a header over here for the actual output to the other board. So that means that we are going with the same pinout as is on the schematic, which means we are going into pin 5, which is this one down here. And then 6 and 7 are connected, so those two can go here, and the 100 PF can just go between them. Hey, beautiful. We need a couple of those 100 PF. So, all right, so we'll go here to the input, to pin 5. I flipped it. Flip it back. So like this. Six and 7 are unity gain, and they go to the 100 PF that's on the other end of this. Oh, perfect. Oh, happy day. Oh, happy day. Okay, so 100 pico. Those are resistors. I hope I have 100 pico. $33, 120, 110, 100. Okay, I got plenty. So I'm going to need 2 of these mofos. Go. Where was that? It's right there. Okay, cool. What I am building, this is Hajiwo, a YouTuber's RP2040 based VCO. So it's a voltage controlled oscillator, and it runs on the RP2040, the Raspberry Pi. What is this? If this is going to be output, that means that the 100 PF connects there, pins 6 and 7 connect there. Okay, so yeah, we'll just do a wire into those and do that like that. Yeah, they're all very, very cheap, but I'm also modifying them by using mutable instruments ins and outs, because it's a 3-volt microcontroller just like any other. So I figured I'd use a really good design instead of a design that was supposed to be cheap. Which probably makes little difference, but I wanted it to be a little bit more fun and interesting and challenging and weird to alter the deal. That, and then this one, we'll get a wire. It's funny, you never know who follows the synthesizer stuff. Never know which viewers I should give the raw story to or the simplified story to. Funny, I didn't have to cover that pin. I could have just left it open. Oh well. Oh well, I guess that's just how the cookie crumbles. What am I doing? Doing it that way, I guess it's fine, but then it, see, it's like poking out down there. It's poking out a little too much. Let's yeah, do the whole bottom piece. Bring this over. Where's my hook? There it is. Where's my hook? That's hard to solder because it's like the wire's like popping up. And I only see what you guys see. We have the same vision on this thing, so oh yeah, it's all jacked up. Hold on, it's all jacked up. There you go, try that. Still partially jacked up. The wire has to be in the way for this to work. Yeah, these are not fun to solder, these connections. They are, oh, the soldering iron then turns off as if to just completely just pile on all of the things that annoy me. The vias like suck the solder away from the joint. I don't like them on this type of design. The way that I like to do this type of design is to have square pads that are only on one layer. They're only on the top layer. And so your bottom layer is entirely dedicated to just hiding all the wires. I love the idea of dirt cheap modular. Yeah, it is. There's a lot of boutique, like super duper expensive things. And like, I look at it like a money making scheme, because you could practically print money with some of these modules. So finding Speedy Cat linked me to Hajiwo's YouTube, and I was like, this is refreshing. Like, this is just refreshing. It's just nice to see somebody building these things out of the like modern dirt cheap stuff. I don't have to go dumpster diving for a vacuum tube in order to build the module, or give somebody $350 for the spring module that's like 4 resistors. I do want to make one of those spring reverb things though. Those seem pretty cool. I could use the solder sucker and remove just a little bit of solder from that joint, but I think that's fun that it's like that. if I had really dedicated myself to it, I could have tried to build the most cursed module possible. So I need 100 pico to ground. Where is ground? Ground is like around here. So if I just do it out to this hole, I think I can access, well, I think that one, that's a ground from 3 volts. So I think if I go straight up, if I go out this way, do the 2 capacitors touch each other? Oh, in the worst ways. No, they don't. Okay. Yeah. God. Or I think a great example of this is the vac troll. So somebody decided to call an opto isolator a vac troll in audio stuff, right? And I don't know how far back these parts go, but the vac troll is an isolation that also does a little bit of compression of your audio signal. The reason it can do compression is because the LDR, the light dependent resistor, can only get so resistive or open. And so they call it a vac troll, and there's a company that makes vac trolls, and you pay a lot of money for these vac trolls. All it is the Circuits 101, Timmy's first circuit project, of putting a light-dependent resistor in a bit of shrink-wrap tube with a diode or a lamp. For 20-month anniversary, 42 months. Smoke them if you got them. 420 blaze it. All that fun stuff. Hey, Chester Willard, thank you so much. I really appreciate your snark in my community. My community pops off when I'm streaming. Nobody watches me. They're all in my Discord. They're all in my Discord being belligerent fucks, and I then have to catch up with it afterwards. I made a big mistake in that I'm building the part of the circuit that's like really, really easy to build and compact on this side, the side with all the room. I need a 10 microfarad electrolytic capacitor. A 10U. 10U. I guess it doesn't really matter if it's, I'll try to honor the circuit and put the right thing in. It's true. Yeah, it's like every time I'm done streaming is the most activity I've ever seen on Discord. Ridiculous. 10U, and this thing is not really going to be seeing any more than 12 volts. It's an input. No, it's an output from the micro, so it's really not going to be... It is going through a unity gain amplifier, but then it's still going to be only 3 volts. Hey, Hiccups, how about you give me a break, man? You know, just give me like some breathing room. Whew. I'm trying to talk to my peoples over here, and all of a sudden my diaphragm wants all the attention. You could probably steal a 10U from something, but I don't think that's going to be too prudent. My fingers are too nubbly. This is a 1U. Come on. 10U. Daddy needs a new pair of shoes. 100. Damn it. We overshot. I don't know what the rules are. 6.8. We're looking for 10. 6.8. I'll probably be one of these little tiny ones. 1. I could always use the surface mount ones, but I think they're too big for this design. I really don't have a lot of room here. This one's 10U, and it's got these short little leads. And it's coming from there, and it has to go to the next resistor, which is a very specific one for some reason. This sucks. I don't have any room to work over here, and I've got to do some cursed stuff with very specific values of like 24.9K. And I've got kind of a big circuit here. I guess what I can do is take... Oh, but that 100K needs to be in there. Yeah, I can't. This has to... The output of whatever I'm about to build has to go all the way back through the header to the socket, to the output socket at the bottom of the board. The bottom right. It's a lot of parts. 1, 2, 3, 4, 5 in the circuit that I'm about to build between pins 1, 2, and 3. 3 goes to ground. At least we got that going. So this one goes between the two parts of the circuit. Did we didn't feed ground to the 100p yet either. Okay, let's see here. Try to visualize our circuit ahead of time, figure out where we can actually build this piece. We've got 4 connections here, and then our output here and here are for, like, these are the inputs, these are the outputs that go to the micro. Micro's also going over here, and then whatever this stuff is going to filter it out. Oh my god, I don't think I have room to build this. I think it's a little bit cursed, unless I drop down to the other layer and do it there, because this is power and ground. Let me double check that. Maybe I got it all wrong, and we can actually just pull all these parts off. I can finally die. Let's see. No, we got it right. So our minus is going to be -12. So I can't use that as ground. That can't happen. Well, luckily we're in the, actually this is the +12 area. This is the -12. That goes all the way over to there. Jeez. Okay. So this is going between the two halves of the amplifiers, and it goes from this pin, but I don't have space for it. I like jump over to a clear area. And it's going from that to pin 2. This one goes to ground, this one goes to the rest of the stuff. And then that goes to ground, and then that one is output, pin 1. So if I do it here, it would go like this. Actually, if that one's going to ground and I put this one here, that means that, okay, hold on. I think I might be coming out of the woods here on this one. Although this capacitor is way too close to the edge of the board and the headers, but I can just deal with that. Oh, we should have done the caps underneath. That would have been a better idea. This thing is now blocking all of my work area. How do I work with this like this? This is crazy. Or I should have done the capacitors on one side and then the chip on the other. Oh well. Oh well. So let's envision the capacitors living right here, between these two. This one will go diagonally down that way, and we'll have ground. What's funny is that, yeah, ground and negative, that could have been done over here, and it would have been in a much better spot. A much, much better spot. Well, that's what happens when you wing it. Things get a little weird. This one is also, well, this one's ground. This one's ground. This one's -12. If I go, that's not a good idea. Nah, we'll have to do that differently. Okay, so I'll take this one and solder it and go down to that diagonal hole right there. And take it from there on the other side of the board. Well, or I could just do wire all the way up. I'll do wire all the way up. Let's wire that to ground. There's a lot more little circuit connections that I still need to make. So things are a little bit disorganized. A little bit disorganized, and I'm going to have to figure this out. So where is the end? There it is. This is like my galaxy brain is sparkling right now. I'm using 100% of my neurons. I'm foaming at the mouth. This could have been a lot cleaner if I was going to like YouTube this. Then whatever the next revision of the board is would probably be what I would show. But since we kind of were playing it by ear as we go, this is going to be a horrible nightmare of a circuit. Hopefully it'll still work. If it doesn't, I'll throw it away. Everything on here is like $1. Snippers, snippers, snoopy doopers. I'm gonna snip this nice and short. And then what I'll do is I'll solder the wire directly to the amplifier, and then just drop it into one of the holes. That does not feel like I cleanly did that. Yeah, I didn't at all. Not at all. Why is that so cursed? Is the iron on? Yeah. There's always these little annoyances. All right, now I need to actually drop that in. So take the wire. I could just keep it up on the surface. I should drop it down. That'll make more room for other stuff to exist. So there's our wire, and then we have an additional ground that we need to bring to here. That's our VCC. That's our 3 volts. Damn it. We're right next to the 3 volts. That's the ground, though, right there. So we'll just take this down here. I can't believe that's right next to 3 volts. 3 volts needs to go to a bunch of different places. As does ground. All right, so there's that. Take the end of that and strip it. And actually, we're going to go to here. So I'm just going to do a little bendy boo right at the end. There's our ground. There's a bunch of little stuff that we got to still pick up to get this thing functioning. I need tweezers. Tweezers are not a substitute for my finger pressing down on the wire. Hello? There we go. I was about to be like, bro, what is going on here? Okay, so there's that. And that back a bit, I'll just anchor it down. Tiny soldering is hard. It's not so bad. Get used to it. My only concern is that I do a connection like this and I can accidentally hook it up to something on the top layer if I'm not careful. There's nothing in that area, luckily. All right, so we've got ground to pin 3. Negative 12 has to come from here. So let's get a, what is negative? What's the color for negative wire? I'm gonna make it yellow. I'm gonna do yellow for negative 12. I don't really know what the official color scheme is supposed to be, but I dislike this yellow wire, and we're only using negative 12 in one spot, so I can use up some of my horrible yellow wire doing this. The jacket is like a slightly different material. Maybe it should come from here. I mean, is that legal? Am I allowed to do that? What the? Get in there. What are you doing? Oh, it doesn't want to do that. It's a little bit too large. I can make this work. I can make this work. Gotta push this down into there. It would work much better on the other one. That one has more room up there. There we go. I gotta assist it. There it is. Yeller. Now here's where it falls through and I get really pissed off. Hold on. can't see what I'm doing. Oh, there it is. And that'll be our negative 12 volt connection. Pull that up a little bit more. It's like scraped off some of the jacket. All right, come in from over here, do a little left-hand soldering. Why did it do the most cursed thing it could possibly have done? Which I was going to snip off the little end of it, but when I tried to flatten it to the board, it just went AWOL. All right, I'm going to clean that up with a knife. There's all kinds of burnt crap in the area. What in the world? Oh, that's the other wire. Oh, did I totally crush that? The ground wire. Oh boy, messed that one up a little bit. I forgot that it was there. That's what I was crushing down on. Oh boy, that was a bad move. I forgot that was there. That's why I totally smacked it. I completely destroyed it. All right, it's fine if it's like this. I'll just get rid of the jacket in that area. This is a ground wire, and then this one is negative 12. Those are connected. So we got ground and negative 12 on there. Positive 12 is going up here. That'll be a different one. And then I need to actually route the negative 12 wire over to minus 12, which is pretty much the only place I'm going to need it, is here. So if I just, I don't want to leave that edge clear. So I guess we're just going to go above and just go straight to it. Strange. It's a strange little arrangement. I guess it'll work. This jacket. The jacket on this stuff is obnoxious. Come on. Help me out here, bud. Jeez. What you end up doing is you end up pulling it too hard, and then it'll either break off or alter something and just not sit cleanly. Oh, I need way more jacket than that, actually. There we go. And then suddenly it just works. Todd Howard, is that you? Doesn't need to be this long. What are you doing? There it goes. It's not, I'm pushing down on it and it's not soldering. What's going on here? It's unfortunate that I got so space restrictive on this thing. It makes me kind of want to like tear it down and start over again with the knowledge that I now have of the structure of this circuit. But I'm gonna plow on and not deviate. Okay, so that's negative 12 connected, positive 12 connected. Now we got to think about the other end of this circuit, the output of the audio. Yeah, plus, minus, all connected. That's a little weird looking over there. Let me just scrape away a little bit of that. A little bit of the nonsense that we have. Oh, you're not soldered. Oh, What the, what? Huh? What the hell? All that I did, all that stuff that I did, and this is just not soldered. I think it pulled, I think that was what that little tug was when I was working, when I was trying to strip the other end, is that I think it was cold soldered and it pulled out of its cold joint. Noxious, that's what that is. Is there like a book of layouts, like arrangements on perforated prototyping board for amplifiers? Because there's an optimal way to do this, and obviously I'm not doing it, but somebody could easily put together drawings of how certain circuit structures look, what they look like when done on perforated prototyping board. Get the light a little closer. There we go. That would either be a useful thing to take notes on or to make. So the capacitor goes between these two. Wait, no. The capacitor goes between this and this one, which if I put it here, I would need this to come around with the capacitor. The other alternative is using a surface mount capacitor that I don't have space for. Hold on, let me see here. I think I have, yeah, I got these. And this one is, what was that value again? What was the value of my 10U? 10U, these. This is a much smaller capacitor than the one that I wanted to put in. It's also overwhelmingly large for this area. I mean, I guess if I took it from over here, but then I'd have to jump under the output line again. And I don't have room over here. It's coming from that corner to this corner. There's plenty of room here. Plenty of room just like to the side of the whole circuit that I've built. It's just I've painted myself into a corner. All the room in the world right here. None of the room right here. Ah, that's really annoying. The signal's coming from here. Or wait, it's coming from the output, which is here. Pin 7, right here, which is also pin 6. This pin. So I guess I could just put this up here. That's maybe we go further away. The stripe is negative, so it actually needs to go the other way around. I mean, or I put this capacitor under the board, but I don't think that's really a great idea. Also don't know where this would connect underneath, because it's got these long legs. Surface mount capacitors are kind of cursed. Unless I use the through hole and I put it here, like this, which I do have room for. I want to keep these open because I want wires to come up through them and go to the resistors, but this does actually fit there, and if we're going away, I guess I could do here, and then I would have to do a wire from there to a resistor and then to pin 2. So that goes in here. So that, I mean, that kind of tracks. That works out pretty well. I think if I twist it like this, if I get it twisted, and then I'll bridge that underneath, and then I'll do a wire, probably maybe even from here over. The wire would go under the board and then pop up over at pin 2. Okay, that actually works. Oh my god, my dog just popped off, barking at something. Oh yeah, look at all the wire that fell through. What the hell? Why is that such a long wire? Okay, well anyway, I gotta get one lead of this thing soldered so it holds in place, and there's not enough lead poking through for me to have it hold itself up. I think. Yeah, I'm not going to do that. It makes reworking something really annoying. All right, come on. Position myself for this just right. Damn you. All right, we're going to do it the dumb way, which is to load solder up onto the iron and then put it onto the pad. You're not supposed to do it that way. That makes cold solder joints. That's the wrong way to solder, but sometimes in a pinch, when you're trying to anchor something, it's the only option. You have to summon the old gods. Use the forbidden technique this one time, sensei. And this one just goes over to its buddy right there. So I think I'm going to try to finish this one up this weekend on my own, just to get it done. And then maybe armed with the knowledge of what I need to do with the other circuit, we'll work on that on Tuesday, and then we can test both of them. Depending on where I get to this weekend, because I've got a lot of uploading to do. I have a lot to upload. I have so many. It's like 275 videos I still need to put up and make thumbnails for, and figure out what the hell's going on in them. And then, somewhere in that process, I will discover myself. And I will touch myself as a result. No, I will actually be able to get projects that are at a certain point and have all the footage for them and have them in playlists, and I'll be able to edit video. And I'll be able to make 20, 30, maybe 40-minute videos where I talk about the design and the build and all that stuff. So where are we going with this capacitor? From the negative end of the capacitor, we go to a 24.9K, which is a very strange value, and then we go over to this right here. So a 24.9K, well, I could put that under it on this leg. On the negative leg? On the negative leg. Why can I see leads? No, that's fine. So 24.9K, and then it's got to do a wire. So let's see here. What value of resistors do I have? These are like cursed values. I don't know why that's 24.9. But I'll follow instructions, and maybe one day I'll buy a bunch of 24.9 precisions. The way I did it was I put two values in parallel, because I don't have decimal values here. $24, $27. I got plenty of 24s. 0.9K is 900 ohms. So if we put them in parallel, 910, 820. 24.91K? Is that cursed? We'll do it. Two resistors hanging out in a hot tub, 6 feet apart. So 910, and actually I could, if I was doing it in series, I could use two values that add up to the number. Actually no, because we lose the decimal places as we go up in value. So it's not like I could put half of 249. Yeah. That dog is barking. She's barking at her friends. There's 910. 910. And then we get a 2.4. 2.4M. Not what I was looking for. There we go. 24K. I wonder how that maths out with everything else. There's got to be some kind of equation that we're taking 24% of 100, because the other one's 100K. 24.9% of 100, and then we've got a 1K on the output. It's like, but that goes all the way, that goes to a different part of the feedback, so I don't know what's going on in this circuit. I think I knew at some point. I think I looked it up at some point and I knew, but I don't know anymore. Now, let's see. I wanted to keep these two, no, it's these clear. And then these two are from the top of the thing, so I guess we'll go this way. We got two resistors, so if I go a jump like over and up, I guess that'll be adequate. This isn't going to be very reworkable. If I need to change something's value, it's going to be very, very annoying indeed. I really should have been marking off what I've been doing as I go. If you take a copy of your schematic and you build it like this, it's easy to get sidetracked and lost about what you're doing. And so you mark off all the things that you do. You cross out the parts that you've built. I didn't do that. I did not do that. Where's it going from here? Oh, it goes back into the op amp. That's right. So it's got to go, it's got to go over here, but we didn't have the ability to build out this way. That would have been nice. So I'm going to have to do a wire that goes all the way over. So there's one, and let's do the other, and I'm going to do that at a right angle to that one. To make 24.9K, which is a mathematical number. We need that value to be precise. And ours is 24.91, which is annoying, but it's fine. We'll get imperceptibly less gain out of our amp circuit. So then from there, we go to pin 2. Pin 2. Okay, pin 2 is where? Pin 2. Sounds like a curse. Pin 2 is right here. So that should come up in a wire right here. Here, here. Shame I couldn't do something else. That's fine. That's fine. That's fine. I'll use blue wire for this. What's right here? I think that's more of the stuff that we need to be careful about. That's power plus 12. Capacitor goes over to here, and that hole is there so that I can put a wire up through it, although I could come from over here. That's going to go to an input. So that goes to an input. This one could go to an input. I think I can use that hole. Wait. That one. Actually, no, I don't need one on this side. I can just go directly. I'll just go direct. It's not actually soldering in. It's just kind of laying down on top of the solder. Come on, buddy. Give me something to work with. Pop that off. Pop. Nope. Pop it off more. Not popping it off enough. Okay, and then we are above this one. See, really, the bottom of the board is supposed to hide all this stuff. And there's going to be a lot more of this because there's going to be a lot more connections that I need to make. It's kind of cursed that we're already doing connections like that. Okay, and then pop this off. I could do this all day, and I am. And I am. I try something. I'm gonna try something. 1.5 million years ago. Oh, where do they go? They're not in here. Never mind. I was gonna try using those Japanese scissors that I bought, the really weird looking ones, to strip away the jacket of this thing. I need like tweezer scissors. Tweezer scissors. Twizzed scissors. Twisted scissors. See, it doesn't really work. My fingernails are still the best thing. Those are as close to tweezer scissors that I have. Although I can do the soldering iron technique, which is just rub the iron on one side and then the other. And then that weakens the jacket, where I can then use the tweezers to just pluck off its dilapidated remains. That leaves me with a little bit of exposed wire that I can then manipulate into position. Twisted transistor. There's also the Twitch user Twisted Scissor that is a buddy of mine from Virginia. There's that connection. That's a great name. Yeah, it's a good name. I like it. All right, whatever. That looks connected enough. So now we have the 24.9K, the 10 microfarad, and now the remainder of it is that scary looking thing. We got the ground connection too, so we need a 47P between pins 1 and 2. That's going to be kind of hard to do. And then, oh boy. So that would basically just be 47 pico right there, and then 100K between the output, and then a 1K there, and pin 2 gets a... Okay, so pin 2 actually I should be taking down to this right here, because I can then jump directly over to the pin header where this thing is going, and then have a 1K. Basically I need a 1K here, and then 100K on the output. Damn it. The clumsiest thing I've done today. All right, let's do this. Between pins 1 and 2, I have a 47 picofarad capacitor. So that'll go in here. Let's get the 47P. And then the remainder of the work to do when I get the proper switches is to redo the front panel. Not in the design of the 3D print, but I need to redo, I need to move all those components over to a new PCB, because the hole drilling is going to be different for the on-off-on switches. That was the most obnoxious thing. That's 47P, not 470, huh? Let's go to 47P. That was a real setback, discovering those switches. 47P. I guess I could have built the amplifier circuits on their own PCBs, and then I would have something that I could transfer in. I would have to build it on those little circuit, the little breadboarding circuit things, because some of those have space for you to put little designs like this. They take up more room when you do that, though. They do take up more room. If I go to, that's a little too restricted. I think I have to jump out here. And so 47P between pins 1 and 2, and then between pin 2 and the output, and then the output gets a 1K. Pin 1 gets a 1K on it, which I could put here. pin 2 and pin 1 get 100K. Yeah, I do have to squish this in because I need... Hold on a second. What the hell's going on here? What is that going to look like? The 47 pico between pin 1 and 2, and then between pin 1 and the output, there is a 1K, and then between 2 and the output, there is a 100K. What is that structure going to look like here? How can I make that fit and not be obnoxious? So between pin 1, 100K, no, pin 1, 1K, the capacitor here, and then the 1K and pin 2 get a 100K. So this has to go up in here. Up in here. It's going to make me lose my mind. Up in here. Up in here. Do this before I act a fool. Up in here. Oh no! God damn it. Get back here. Stay right there. Pin 2 and pin 1 are right there. Yeah, it's going to be a little bit weird. Where did my... There it is. Ugh. Ah! Okay. I gotta figure this out. Where am I gonna hold this from? Okay, so between pin 1 and 2, if I move pin 2 up, what's that gonna look like? No, I don't think that works. Because the 100K needs to go right there, and then that needs to go to pin 1, and then this one needs to go in between. I can't move it out or around because pin 2 needs to go to a particular spot. What if I did pin 2 there? And this still goes between pin 1 and 2. Yeah, I think that may be the way that I should do it. Let's just see here. Now I need my 1K and 100K that are simply there to confuse me. So on the outside of that cap, that goes pin 1 to pin 2. And then at pin 2, I also have a 100K that goes to the other side of a 1K. I can't figure this out. Pin 2's here. Okay, hold on. Let me get the resistors. I'll be able to do this easier with the resistors in front of me. Oh yeah, I'm out of 100Ks. Perfect. Let's get at least the 1K in the smaller size. 1K. Oh my god, the last 3 on the ream. 1K. Then I gotta get 100 out of the bin. $100. $100 between pin 2 and the 100K that comes off of pin 1. Pin 2 and the 100, so that would be crossways, and then this is, if we're going into this area, encroaching on these two, this would be where the output is. I guess that's what I'm going to build. Then of course power is going to come in from over here, and I don't know, I'll figure out a way to get these hooked up properly. So yeah, 100K goes to pin 2 to output, which would be this. Well, unless I make output, yeah, unless I do this, output's here. And that puts it right up next to the header. That's actually better. Cheddar. The problem is these two are swapped. If I swap these two, then the one that's right next to the header would be the input from an external CV. So I'll probably have to do that too. So 100 goes between the 1K that comes off of pin 1 and the output. Sorry, and the capacitor that goes to pin 2. Okay, all right, I'm starting to get it. All right, and then 1K goes like this. And I'll have to do a line there and a line there. Hold on one sec. Let me think about this. 1K branching with a capacitor. If I do it this way, then I can just do straight up and down. I don't think there's a more succinct way to do this unless I do diagonal resistor, which is, I don't want to really do. Yeah, I think that's the way to go. What a weird circuit. What a weird circuit. I'm going to swap these two because the 200K is what gets the negative 10 volt reference. So we're going to move that out, and then this is what gets the input. And so I want the input to come into here where it can get to that pin header faster. More easily. More easily. Easy clap. That's going to be a tough jump. Yeah, that might need a piece of wire on it. Unless I go get an 0805 200K. But there's no room because that other one's right there. Yeah, I'll just put a little piece of wire in there. That gets a little piece of wire. Okay. Oh, good thing nothing's soldered. Let's get solder on the end of this wire. Yeah, I'm not going to be able to resist the temptation to work on this while I am uploading video, because there's little break times in between where things haven't fully uploaded yet, and I've already done all the chapters. So I will not be able to stop myself from working on it. Long stream, this is normal. This is a normal time. I usually go pretty. Sometimes I end pretty early because we get to a stopping point, but this is the kind of stuff that like I was made to do. So I don't stop working on this stuff until I get to like a good place with it. All right, let's get that little soldered connection in there. This would have been a lot easier. Chat, you got to stop me next time I try starting to work on this stuff. Whenever I see builds like this, I always think of Frankenstein. I totally missed that comment. I don't know why I did. Pre-builds before ordering home design print circuit. Yeah, this is the second step of the process. It would be napkin, breadboard, solderless breadboard for proofing out your concepts, and then you'd make something like this in order to make sure that it works in, you know, like a semi-permanent manner, and then you would go and design a circuit board. But $5 circuit boards have completely undercut this step. This step is useless. The only thing that you can take from this and the streams of me doing this is that all the techniques that you're supposed to be putting into the final thing. These could actually have been done at a right angle. They could have come out into this part of the board over here. I kind of messed up and squished everything up against the side. Managed to come out on top somehow by the seat of our pants. But the next time it comes down to building a board like this, we are going to order a board. We're just going to make a circuit board. Why did you desolder? What the? This was a cold joint. A cold day in joint. What up, Complex Swede? How you doing? You keeping it complicated? You better be. These will be outputs or inputs or whatever later on. All that solder just left. It went straight down to the lower layer. God damn it. Oh, that pisses me off so much. Now there's no solder for me to solder this. What? Like, I didn't ask for this. .jpg. Okay. This is starting to get really vexing. My brother in cripes, would you just solder? Where did all that come from? Okay, so that means when I drop a pin header on it, I'll already have these connections sitting here. That'll also be a visual reminder of me for where the connections are. Okay, so that would be that stupid circuit. Let me double check that. So pin 1, I'm going off of the schematic over here. So I'm looking at pin 1, pin 24.9 over to pin 2, and then, you know, these connections. So let me just take a look here. Pin 1 in this case goes to both a capacitor and to a 1 kilo ohm resistor. So that would be this one and this one. The capacitor then goes to pin 2. This is why we check our work. If I'd moved this circuit over a little bit, I would have had all the space in the world to make this. So the thing with pin 2 only goes, yeah, it doesn't go to any kind of an external connection, so I don't need to run that anywhere else. So I'll just cut that right there. It's a little short for a wire run, but whatever. Go. Now, as soon as I solder this, it's going to melt both ends. It's like all the solder falls down and then it doesn't solder the top. And so once I'm done this, there's going to be a big booble of solder underneath it. Okay, so there. Okay, so that goes to pin 2. Got it. Goes to pin 2. Pin 2 goes to a bunch of stuff. It goes to a 100 kilo ohm resistor. That's that right there. It goes to the 47 PF capacitor. That's that right there. That then goes to pin 1, and the 100K goes to the junction of the 1K and pin 1, as well as the output. Got it. Okay, that part of the circuit is done. And pin 3 goes to ground. That ground wire is right over there. Whew. Man, that was weird. That was pretty weird. Okay, I think I'm all streamed out for today. We didn't get too far. We got a lot of stuff done with the singular VCO, and that's good progress. I got all of the op-amp circuits down. I still need to make sure everybody gets power and the signals go from the microcontroller, which I'm tempted to not do that fully and test the circuit first, but maybe just for sharts and gargles, I should do it like fully build the circuit and power it up all in one, and I'll wait for you guys to do that, of course. So I will work on this a little bit this weekend. You can see some of the inefficiencies here. There's a lot of open space in this portion of the circuit board. I really could have shifted things to be in better positions if I had known how they look at the beginning, and I just didn't. So this circuit board will then mate with this circuit board. I need to get the proper switches in the mail, redo this one. I'm starting to run out of these little boards. These are really good for 6U rack things, but then these will attach to each other with pin headers. And so I'll be able to peel off the pin headers if I need to, but this should stick on pretty well just with pin headers. I don't need screws and standoffs. And that'll be the VCO module, the digital VCO module. That'll have all of the whistles and bells, hopefully, of a nice VCO. I wanted to win. I wanted to finish something today, but we didn't really get... We got further along, but this stuff takes time when I'm explaining to you guys everything that's going through my head. So thank you again for joining me. Let's see if the end card has been updated. I know OctoJ hasn't asked me if I'm going to do anything on Saturday, so we'll just see what happened. 3 days, 19 hours, 19 minutes, 17 seconds. At this point, the Saturday streams are a surprise if they actually happen. And I don't think I'm going to do one because I'm going to spend Saturday and Sunday just uploading. I just need to get more and more stuff uploaded so that those VODs continue to flow out daily, even though they're not doing that well, but who cares? Okay, anyway, thank you guys for joining me. We built a little bit more of this circuit. I showed off some techniques. We will be back on Tuesday. And on Tuesday, I will be doing more stuff. I don't know what. We'll figure it out. We know what I know exactly what I'm going to be doing. You guys are watching a man lose his mind on camera. We will be doing testing of the circuits. Hopefully, I'm far enough along that we don't have too much extra to build. And then the next time we do this, you guys got to make sure that I do it in Fusion 360 and not with the perforated prototyping boards. I just have a lot of parts lying around that I need to use up. So, all right. I don't know who's on right now. I'm not connected in Twitch. Let me just quickly look and see if there's anybody that I super desire to raid. Rabaz is on. He's doing Enshrouded more. Who else do we got? Oh, wow. It's not a lot of people today. Huh. I don't see... Paleontologizing is doing his thing, too. So if you guys want to check out dinosaur stuff, I'm not gonna throw you over there. You'll have to go in your own volition. But I'll be back on Tuesday. In the meantime, that Discord link, that's where I am. That's where you can find me. And I will catch you guys at the other end of the weekend. I'll see you later.